Well, good afternoon, everybody. Welcome to the Alliance for Sustainable Building Products Healthy Buildings Conference 2022. My name is Simon Corby. I'm Director at the Alliance for Sustainable Building Products. This is our 6th annual Healthy Buildings Conference. We've covered a lot of ground over the previous years, all available up on our website. We are recording this session as well. So we'll be sending this to everybody who's attending so you can watch it again. So we've got 2 sessions and our first session, we've got Professor Nick Carslaw, Professor Avtar Matharu, and an old colleague of mine, Andy Tugby from Human Nature. And so Nick needs to get away. I'm going to hand over to Nick now and ask her to share her screen. I'm going to stop sharing and we're going to come back to my slides. There's a few more intro slides that I'll show once Nick has done. So if you've got any questions for Nick, just pop them in the Q&A. We'll either ask them as she's finishing or if she needs to get away, we'll send them to her and ask her to respond to them over the next few days or so. So over to you, Nick.
Okay, thank you, Simon. So can you see my screen okay before I start?
Yeah, do you want to make that full screen?
Oh, I thought I had.
It's sort of...
that's a bit strange.
There we go, that's better. We've still got the slides down the left-hand side, but that's okay.
I don't know why that is. It's showing on my screen as being full screen, which is slightly peculiar. Is that clear enough if I carry on?
Yeah, that's fine.
Like this? Okay. Okay, so hello everyone, and first of all I'd like to say thank you for having this opportunity to talk to you about my work on indoor air quality. And here at York we do lots of research on indoor air quality, and we're particularly interested in the routes to form pollution indoors, and particularly the chemical pathways behind those routes. But what I'm going to focus on today, given the topic of this conference, is some of the work we've been doing on building materials and how they can affect indoor air quality. So just a brief overview of what I'm going to talk about. I'll talk very briefly about why I think indoor air quality is important to study generally, not just with building materials, some of the sources of indoor air pollution, and then start to focus on some of the modelling studies that we've been doing at York, focusing on internal surfaces. And then at the end, I'll just briefly mention green building materials versus more traditional building materials, and this should link really nicely into Avtar's talk, hopefully, and then just finish up with some summarising remarks. So why study indoor air pollution? Apart from the fact it's a really interesting topic to study, if you think about what's happened over the last 40 or 50 years in the UK and lots of other developed countries, there have been some behavioural shifts that mean that air quality in buildings and our homes in particular has become more important. So looking back, you can see from this rather bucolic slide here, children used to be chucked out of the house in the morning to go out and play, and they came back at tea time. And I know this is a rather stereotypical view, but we know that children spend far more time indoors now, whether they're on their phones or the Xbox, etc. And this kind of rather simplified picture can be seen as a proxy for the behavior through the whole population. So adults through our working lives now, we might have had jobs in the past where we're working out in the land, farming, for instance, and now most of us spend most of the day in an office block. So there's been a shift in spending more and more of our time indoors. And in fact, it's estimated that in developed countries like the UK, that's probably about 90%. And if you think about what that means you have to be spending about 2.5 hours every day outdoors, and probably that's a push for most of us, even to do that. So that 90%, keep that in your minds. If you look at this figure here, what's happening on this one is we're looking at the kind of degree of building tightness over time. So we're starting off 1940 on the left, going through up to 2016. It's as up to date as I could get the data. And what we're looking at is the air change rate in a house. And obviously this is the year of construction of the building. And you can see that over time, what this is telling us is that buildings have become more and more airtight. So we're spending more time indoors, and we're spending more time indoors in more airtight buildings. And then finally, this is the consumer index, and you might think this is a bit of an odd thing to be looking at. So we're going from 1900 up to about the present day, and you can see it's fairly flat for the first half of the last century. And then once the Second World War ended, consumerism basically took off. The reason this is important is because we know that new things emit more chemicals. So if you buy a new carpet or a new piece of wooden furniture, you quite often have a distinctive smell with that new item. And that's because we know things off-gas more when they're new. So if we're bringing more new things into our homes more often, we're introducing a source of chemicals into our homes. So if we take all these things together, we're spending more time indoors in more airtight buildings, and we're putting more things into those buildings that are off-gas, like building materials. And then on top of all that, obviously, we've got the added issue over the last couple of years of the COVID pandemic, which has sent us indoors in even larger numbers. So this is why I think this is why we need to study indoor air quality, and particularly now. And the whole COVID pandemic has made us think much more carefully about what we're being exposed to indoors. So thinking about sources of indoor air pollution, there are many, and I'm just going to highlight some on here. So cooking is an obvious source of pollution indoors, particularly when you do things like frying meat. So we know that you can make lots of particles through that process, but also things like cleaning, burning scented candles. We know there's lots of aroma fragrances that we use in our homes. Perfumes, for instance, are obviously emitting volatile compounds. These plug-in air fresheners are another source of volatiles indoors. And then people also emit compounds. So we won't go into too much details because it gets a bit grisly, but people breathe. And when they breathe, they're breathing out different chemicals as well as carbon dioxide. There's a whole range of other things that we breathe out. And we also know that indoor pollutants like ozone can react with stuff on our skin surface and lead to a whole host of other products being emitted. So if you've got lots of people in a badly ventilated space, you can get quite significant concentrations of these skin oxidation products. And then finally, what we're going to be focusing on today is things like furnishings and building materials. So we know that some of these things will give off direct emissions. So that's the smell when you buy something new, like I was saying. But we also know that some of these chemicals that are given off by things that we use or do in our homes can go on to react and form other products, and some of those are harmful for health. So we're looking at these types of processes at York. So we're going to focus on emissions from surfaces and thinking about building materials, but I just wanted to explain to you the different processes that can happen. So let's imagine this is our surface. So this could be a bit of wooden flooring, a bit of plasterboard, a bit of carpet, whatever it is. And we have various different things that can happen. So one thing that can happen is that we have primary emissions. That means that chemicals are emitted directly from that surface. So that's the process here. Now, once in the air, these emissions, these primary emissions, and we tend to think about volatile organic compounds. That's what VOCs stand for. So think about things that you can smell, to simplify that. We know that once these are emitted, they undergo a lot of reactions indoors, and they can form secondary volatile organic compounds. Now, the other thing that can happen at surfaces is that you can get pollutants that exist in the indoor air, like ozone, and we know that this comes in from outdoors, it comes through windows. So this ozone can actually stick to the surface, whatever it is, particularly like sticking to carpet, as we'll see in a minute. And then you can get a chemical interaction at the surface, and then you can get secondary volatiles given off. So you've got all of these processes going on at the same time. And for some surfaces, the primary emissions will be more important. For some surfaces, the secondary emissions will be more important. But something that's quite important to consider is that these primary emissions fall off with time. So that's why you can't still smell your carpet a year later. Most of that primary stuff comes off in the first few months. But these secondary emissions can keep going on over time, because as long as you have a new source of ozone, you can keep getting this surface interaction. So let's look in a bit more detail at some of these processes then. So we're thinking about this part of the scheme here, these primary emissions, and we know that building materials can be quite major contributors to VOC concentrations indoors, so these volatile organic compounds. And I've listed some of the ones of most concern here. So we've got benzene, which is this aromatic ring. And I'm sorry if this is bringing back painful memories for anyone who hasn't done chemistry since they're at school. Formaldehyde, which is this substance here, and another aldehyde called acetaldehyde here. This is toluene, and then this is a xylene. So we've got a mixture of aromatic species, and these are called carbonyl species. And all of these have implications for health. So we know, for instance, benzene and formaldehyde are both carcinogens. Now, if you look at paint, paint contains some of these volatiles, typically at about 5 to 8% of the mix. And it includes some of these compounds that I mentioned above, like the xylenes and toluene. Now, the next slide might be slightly scary for some of you, but I just want to show you what can happen when toluene is released into the air. And what this is showing is kind of a simplification, would you believe, of the possible chemistry that can happen when that toluene is released. So that's this part of the scheme here. This is where the primary emissions that are emitted into the air can undergo reactions to form secondary species. Okay, so we're not going to worry about the detail. I just want you to understand that it gets quite complex. Now let's go back to this part of the diagram over here. We're going to think about what happens when something like ozone interacts with a surface. And that actually gets quite complicated because it varies a lot depending on the surface. So here we've got some different surfaces. We've got carpet, we've got lino, painted walls, hard furniture, wood, countertops, and the human body. It's a bit of a strange expression, the human body. I'm not sure what other bodies would be in a home. And what we've got here is a box and whisker plot. So what these show is the lines incorporate the maximum and minimum values, and the boxes incorporate the 25th to 75th percentile values. And then the little green line, hopefully you can see that, is the median value. So what you can see from this is that there's lots of scatter. And the reason for that is that depending on things like the age of the material, the way that these measurements are made, you can get a wide scatter, and that's particularly the case for painted walls. So you can see for some of these surfaces, we've got a reasonable number of measurements, so 29 on walls, 40 on carpets, but for some of them, like countertops, we've got very few measurements. So a lot of scatter. But you can see some trends. So for instance, we know that ozone really likes to stick to carpets. The reason for that is that carpet has lots of fibers, and ozone can get inside and around all those fibers, and it sticks very effectively. But for other surfaces like lino, you can think that that's quite a flat, solid surface, if you like, and the ozone is much less sticky. So the type of surface will determine how much ozone can actually stick to it. And that's exactly the same when we think about this part of the process. So this time we're looking at the yields of how various aldehydes, so these are types of VOCs, and the reason we've picked up these in our work is because these all have potential health effects. And we can see again that the yields will vary depending on whether you have a new or an old surface, depending on the type of surface. So different carpets will give you different yields depending on the particular material. So it's all very complicated. And also, we only really have relatively few measurements. Nevertheless, what we've tried to do is to put some of this into a model to see if we can get some more insight. And what we've done is we've assumed a typical apartment as laid out here. So actually we went to the literature to see what a typical apartment looked like. And these are the values that we got. So one interesting thing here is this typical one floor apartment. If you look at the unfurnished surface area, it's about 70 square meters. But by the time you've added in all of the surfaces in that space, you actually get 4 or 5 times more surface. So this is a really big difference between indoors and outdoors, actually, is that the surface area is much more important. So the surface area to volume ratio is much higher. So this plot here is now showing you what percentage of the total surface indoors is due to walls or furniture or whatever. So you can see that a big proportion of your indoor surface area is taken up by painted walls, and that includes ceilings as well. So this shouldn't surprise anyone, because if you think about any building, it's walls and ceilings that are going to make up most of the surface. But you still get quite significant contributions from wooden floors. We don't have carpets in here because we were looking at a typical European apartment, and Europeans don't use carpets as much as we do in the UK. So we then looked at some different outdoor air concentrations. So the reason for that is that a lot of the indoor concentrations of ozone and NOx, NO2 and NO at least, are driven by what's going on outdoors. So that's where that comes from. When you open doors and windows, we get these outdoor pollutants inside. So we wanted to look at different scenarios outside. So what we did was we looked at Milan, which is very hot and quite often smoggy. And we looked at this summer from 2003 when there was lots of pollution outdoors. And then we compared that to a more typical summer a few years later. And we also looked at Seoul, but I'm not really going to talk about that. We were just looking at different cities. And then what we did was we put the some of this information into a model that we have at York. So I won't say too much about this. If anyone's into modeling and wants to look at the model, you can find it here on something called GitHub, where you can store open access code. So our model is completely open. Anyone can go along and play with it. There is an instruction manual with it, so hopefully that's fairly intuitive if you want to go and have a look. But basically what we did is we put in these outdoor concentrations. We put in things like, you know, what time of year it was, what the location was. We put in all the chemistry, and then we put in some information about these surfaces and the surface areas. And then what we can do is, focusing on this part of the process again, we look to see where the ozone ended up. And let's just look at this plot in the middle, because they all show the same proportions. And you can see that when we do that, most of the ozone ends up sticking to the painted wall and the soft furniture. Okay, now there's very different surface areas of these two. If we just skip back, you can see that painted wall is 60%, soft furniture is only 10%. But because that soft furniture has got all of those fibers, it's very fleecy, you can see that you can get almost as much ozone sticking onto this surface, even though there's not as much of it. And then we've also got a significant amount of ozone sticking to the wooden floor. So that's what's going onto the surface. And if we look at what's coming back off the surface, you can see that we get these different long chain aldehydes. And this time, you can see that the painted wall for nonenal and decanal is the biggest source of these emissions. But for things like hexanal, then the wooden floor becomes more important. So the most important surface varies depending on which of these species we're looking at. Okay, so just for the last couple of minutes, I just wanted to talk a bit about green building materials. And the market for green building materials is increasing. It's quite interesting, the whole nomenclature around green building materials and what we mean by that, because sometimes they're manufactured so that the manufacturing process is green. And Avtar will be talking about this, no doubt, in his presentation. So how can you limit the energy when you're making green materials? How can you limit waste? So that could be one definition of green. But it's the same with a lot of so-called green cleaning products. There tends to be assumption that just because they're manufactured in a way that maybe limits emissions in terms of energy, it doesn't mean to say that the emissions are lower in terms of volatiles. So we had a look at some literature that's in the data that's in the literature. To be fair, there isn't that much of it actually. But we did have a look at this paper, for instance, which was looking at exactly this, and they set up an experimental chamber. And basically, they were putting different bits of building materials into this chamber, and then they'd flow ozone over it and measure what came off. And they were comparing green materials with traditional materials. So what we have here is the traditional materials at the top, and we're looking at wooden flooring in this example. And at the bottom, we have the green wooden flooring. And what they did was they pumped in ozone for the first 4 hours of this experiment to see if they could initiate that secondary chemistry. Then they turned the ozone off. And then at 48 hours, they turned the ozone on again. So you can see for both of these plots, you get the increase at the start as they're adding the ozone. And then once they turn the ozone off, you get a decay. And that's the same in both of them. And then you can see at 48 hours, when they turn the ozone back on again, you get another increase in the formation of these aldehyde species, which are all listed here. But notice that whereas the traditional materials are peaking at about 1500 micrograms per meter cubed up here, the green alternatives are peaking at closer to 300. So it does indeed look as if those secondary emissions are much lower for the green materials. But it's interesting that even though, you know, once they stop with the ozone, you can see this very clear decline in the secondary emissions. Notice that they do come back up again once you add ozone. So this is indicative of what would actually happen in real life, as it were, that, you know, every time the surfaces in your home are exposed to ozone, you can still be producing those secondary products. And then this is a nice summary slide of basically side-by-side comparison. So this is the kind of emission rate of the secondary products that they were looking at. And on the left-hand side for each of these pairs, we have the traditional material. And then on the right-hand side, we have the green equivalent. So we've got wooden floors, gypsum board, calcium silicate board, and mineral fiber ceiling. So in all cases, the green products seem to be doing a much better job. And that means they'll be also producing fewer of these harmful secondaries. Okay, so that was a bit of a whistle-stop tour through some of the work we've been doing. But hopefully I've convinced you that we can get these potentially high VOC concentrations indoors, these volatile organics. So building materials are partly responsible for that, but we also have other processes like cooking and cleaning. So it's worth noting that painted surfaces can often be the biggest surface area indoors. And even if, you know, the ozone deposition rate onto painted surfaces isn't particularly large, because of their vast area compared to the other surfaces, they can have large impacts on the indoor air quality. So the green building materials are better for indoor air quality than traditional ones, which is good. Also, that's in terms of both the primary emissions, which tend to be lower. So I didn't show that, but they do tend to be lower, but also those secondary emissions, which I did show you. There are health implications for some of this because these aldehydes aren't particularly good for your health. And I would say what we need is much more information on some of the deposition rates to these different surfaces, particularly some of the new surfaces that are starting to go onto the market. And also thinking about what are some of these emission yields, because you saw from what I showed that the data was quite patchy in places, and it would be good to have some more measurements. So I think with that, I will leave it, and I'm happy to take some questions if there are any.
Thanks, Nick. That's great. So Nick's just got a couple of moments left. If anybody's got any questions, so pop them in the Q&A and we'll field those. I was quite curious, Nick, to see what a green wooden floor was as opposed to a wooden floor. Is that solid wood, or is that a sort of laminate?
That's a good question. I can let you have the reference that I used. There was a paper from 2015, so I'm not exactly sure how they define it. But yeah, I think that's a really good point, because I think green means different things to different people.
It certainly does.
Yeah. And it's the same with cleaning products. Like I said, you have green cleaning products, you have natural cleaning products, and this whole perception as well that natural means good for you, even if it's the same chemical. It's very, very strange. I've seen an advert on Facebook for chemical-free essential oils, which was quite interesting. So there's definitely a perception of natural and green being good for you without the scientific evidence to always back that up, I think.
Yeah, I think that's true. All right, look, Nick, we'll love you and leave you. Thank you ever so much for your contribution. So as a whistle-stop tour, I'd imagine that everybody's got 101 questions now that Nick needs to go. There's a few appearing in our Q&A, but we've sort of run out of time for Nick. So what we're going to do, if you want to keep putting your questions in the Q&A, we're going to ask Nick to respond to these over the next week or so. So we'll send those to her. So thanks ever so much, Nick. Much obliged.
Yeah.
So thank you, and we look forward to working with you, and see you soon.
Lovely. Enjoy the rest of your afternoon.
Thank you.
Bye.
Thanks. So I'm going to just run through a few slides. So our next speaker is Professor Avtar Matharu, Director of Green Chemistry, also in York. And then you'll be pleased to know that we've got a case study. And so my colleague at Human Nature is going to be looking at the Phoenix project in Lewis. So a substantial development that's just about underway there. And now we'll have time for a comfort break and a bit of a breakout room networking session. And then our second session, we've got 4 speakers for you. Dave Kieft is going to be talking about indoor air quality studies and various PAS standards that are being developed for indoor air quality. And then something I'm very much looking forward to, we've got Jean, who's Senior Inclusive Design Consultant at Borough Happel, talking about neurodiversity, something I think we all need to know a bit more about. And then Amanda Long, as Chief Executive Code for Construction Product Information, is going to be talking about the new building product code for construction product information. And then to finish off, we've got Mark McKenna with a case study. Mark's doing some fantastic work at Down to Earth. So just as a reminder, if you've got any questions, pop them in the Q&A and we'll get to those. We'll either unmute you or I'll ask on your behalf. So just as a reminder, so ASVP, we're a not-for-profit mission-led membership organisation, and our mission is to accelerate the transformation to a healthy, low-carbon built environment by championing the use of demonstrably sustainable building products. That's quite a mouthful. So we've got sort of 6 pillars that we work under, health and well-being being one of those, but of course they're all intertwined. So we've got a growing team, I'm pleased to say. There's 7 of us now on the staff, and we're supported by a fantastic board of experts. So we're ever grateful to them. And we're growing, we've got to about 120 members now. We've been going since 2011, and we planted some trees to mark our 100th member. We're a busy bunch. So last week we had our first blended event, so we had folk in the room and had our awards, which were fantastic. 6 great winners. Have a look at our website for them, or if you're going to Future Build, they'll be there. We've got a new healthy paints and finishes group, which I'll talk about in a second. Joe Giddings is heading up the Timber Accelerator Hub, which is looking at mass timber and how we can reverse the choking off of mass timber developments here in the UK. We have a reducing plastics working group, a natural fibre insulation working group. We spend a lot of time looking at embodied carbon and trying to help along with EPDs, tools and understanding that type of thing. And we're very active when it comes to the circular economy and reuse. So our new working group on healthy paints and finishes, which is quite fitting really from following on from what Nick was saying. So it's a new working group and bringing together leading manufacturers and suppliers. And so our group is setting out to do a range of things and agree on consistent messaging, like things like 0 VOCs, which we don't think exists, and we'll develop a code of conduct and fight greenwash, that type of thing. And there's a report that came out a couple of days ago, which is quite sobering, which tells us that paint appears as the largest source of microplastic leakage into the ocean, which was very sobering. I mean, perhaps when you think about it, it makes sense, but it seems to outweigh all other sources of microplastic leakage, and that's fibres and tyre dust. So it's very timely that we've got this paints and finishes working group up and running. Back in 2019, we spent the day looking at plastics. And since then, we've got our Reducing Plastics in Constructions working group underway. And part of our activities there has been to look for funding. And we were successful in winning some funding for eco-surety. And we're working with project partners, Cullinan Studio, Bankside Open Spaces Trust, Mason Morgan Sindall. And we're going to show you just a very quick video, just to give an overview and an explanation of the project. So I'm going to ask Richard to pop that up. And so this is just a 2-minute video, which is anchored by our Dr. Catherine Adams, who's our lead technical advisor. Thanks, Richard.
The construction industry is the 2nd largest consumer of plastic, and quite a bit of that is packaging. Once packaging gets on a construction site, it's very hard to deal with. It will go in mixed waste containers and skips, and then on from that, most of it will either get incinerated or landfilled. The biggest barrier when it comes to looking at packaging in construction is really the supply chain. Products will leave the factory, they'll be covered in packaging, They'll go to site, but when they're on site, the manufacturer really doesn't have anything more to do with that product. We don't have a good understanding of the different types of packaging and what products they're used on. Once we can understand that, we can look at what different solutions we can put in place to manage it more effectively. Plastic packaging is really important. It's there to protect people and it's there to protect the product, but it's all about the right material for the right application. We really need to work across the supply chain, so that's with clients, designers, manufacturers, contractors, and then finally waste management companies. It's really about getting them to all work together, which can be quite a challenge. The ZAP project's really trying to generate a better understanding of what's happening with construction packaging on site. The Ecosurety Exploration Fund will really benefit the project. We'll be developing case studies and then generating best practice guidance and training materials, which can be used across the whole supply chain to start taking action on packaging. By undertaking this project, we really see the bigger goal in helping the whole construction industry reduce their environmental impact and avoidable waste.
Great, thanks, Richard. Yeah, so a bit of an overview of our Ecosurety project, the ZAP there. So that's just about underway. So very exciting project, pleased to be part of that. I mentioned our awards, so have a look at our website or go to Future Build to pick up on those. Next week it is Future Build, so it's, you know, COVID is apparently over, so it's back to the Excel Centre, 1st to 3rd of March. We'll be on a stand E64 there, so pop in and say hello. All of our awards will be showcased there, and we have a seminar on net zero and natural materials on Wednesday the 2nd at just after midday, 12:15. So check us out there and come and say hello on the stand and get to know us. Another project we've got underway is a European project which is looking at problematic waste stream, which is waste duvets. So we're wondering what we can do with that and whether we can refiberize it and turn it into insulation. So that's an interesting project. Keep an eye on that. So do get involved with the Alliance for Sustainable Building Products. We feel that we offer a very competitive membership fee, and we have a free newsletter which you can just sign up to, or you can get more involved and become a sponsor or join one of our specialist groups. So keep an eye on our website, sign up to our newsletter. So this is the team and this is all our contacts. Do drop us a line, we're very responsive. So that's the end of my slide. So I'm going to stop sharing now. So I'm going to hand over to Avtar, who's Director of Green Chemistry at the University of York. So I think this is a look into what's coming down the line by way of alternatives, by way of greener alternatives, by way of healthier alternatives. So binders that are better for us, that type of thing. So very much looking forward to Avtar's chat. So if I can ask you, Avtar, to turn your video on and share your screen. I seem to have lost Avtar. Let me just check. So I can't see him in our list of participants. So
yes, it looks like Avtar's dropped off. So
okay, well, such is. What we'll do then, we'll ask Andy to step forth to the podium, to the virtual podium, and we'll go straight into Andy's talk, and then hopefully during the duration of that, we'll welcome back Avtar. So thanks, Andy, nice to see you.
Hi, Simon.
And over to you. If I can ask you to share your screen and take us through your presentation, please.
Absolutely.
Thanks, then.
How is that? Is that full screen?
Yeah, that's perfect. Thank you.
Lovely.
Yeah.
Hi, everyone. Thank you very much, Simon, and everyone for having me. And let me come in and talk to you a bit about what we're doing in Lewes. My name's Andy Tugby. I work for a company called Human Nature. I want to tell you a few things about what human nature is, what drives us, some things about our process and about what we do, and then a bit more specifics about the projects that we're undertaking at the moment and some specific solutions that we're looking at. Before we go on, I'm just very clear that I'm very much preaching to the converted with a lot of this. So apologies, I don't mean to be patronising in any way, but bear with me. One of the things that drives us is that there is an existential crisis where nothing less than everything is at stake. Human Nature was founded in 2015 by Jonathan Smales and Michael Manelson, two former directors of Greenpeace. It grew out of Beyond Green, which was a leading UK sustainability consultancy focusing on sustainable development. We're predominantly a campaigning business, developing ventures that enable people to flourish and thrive while living within the planet's limits. And something that's become very clear to us, or to everyone for the last few years, is that this is no time for business as usual. And that's, we're kind of galvanized by that imperative. It kind of galvanizes us for the need to go further, faster, deeper in finding solutions, predominantly rooted in neighborhoods and at a scale and in a way that safeguards the planet for us and for future generations. So we aim to make and shape remarkable places and communities with the imperative of what John Elkington calls, and we're adopting the term of exponential sustainability. But how do we do that? So we're developing a suite of tools and methodologies that guide and inform what we do. So this is what we call our circle of impact. So all of our projects are measured against our circle of impact framework, which outlines the kind of key steps that we need to go through in order to achieve exponential sustainability through the way we design, build, and eventually live. So at the centre, there's another quote from Patrick Vallance, the government chief scientific advisor: "Nothing short of transforming society will avert catastrophe." So how does the circle of impact work? So there's a lot of detail on here, and I won't go through everything, but I'll just quickly zoom around. So when we're looking at any of our projects, we look at place. So we look at people first urbanism, concepts like connectivity, walkability, 5-minute neighborhood. When we look at infrastructure, we're talking about renewable energy supply, zero waste, on-site energy generation. When we look at homes, looking at different housing choice, shared living, compact living, self-build, co-housing, varied typologies and tenures, etc. Land use and activities, we're talking about circular economy, maker spaces, community, cultural venues, co-working, education, learning, music, dance, that sort of thing. In terms of building fabric, we look at elements of natural materials, enduring, flexible and reusable materials, concepts we call raw and craft, build and design, energy efficiency, etc., etc. Services, things like stewardship, management, building maintenance, repairs, libraries of things, circular urban farming, composting, food boxes. Carrying on around the circle, behaviour and culture. We judge things by intentionality, bike and walking culture, local slow food, clean energy, communal, social, neighbourly lifestyles. Mobility obviously is a big issue. We look in things like co-mobility hubs, EV hire, e-bikes, cargo bikes, bike shop, freight hub, last mile deliveries. And within ecosystems, look at climate change mitigation and adaptation, biodiversity, geoarchitecture, rain gardens, and the number 10 on that list is quite a key one, we think, and it's this idea of catalytic conversations and the power of doing. So community engagement and participation, creating places where people can come and see things in action. So what are we planning to actually do? So the Phoenix project, Human Nature, we're planning to develop a new neighbourhood on the former Phoenix Industrial Estate, which is a 7-hectare brownfield site in Lewes in East Sussex. So all aspects of the development will embed the principles of exponential sustainability. We embrace environmental, social and economic themes. The built environment has to encompass low embodied carbon in construction as well as in operation. And we're serious about climate change adaptation. So the idea is to help create a net positive, regenerative, sustainable urban neighbourhood and community that fuels a new social imagination, changing where we live so that we might more easily and happily change how we live. So what's the plan? So here's an image of the one of the master plan drawings. So what we're planning to do on the site. So it's predominantly residential, about 650 units. But as well as that, there'll be an abundance of shared spaces and places, communal gardens, food growing, co-working, creative and community spaces, health hub, community canteen, arts venue, exercise facilities for all ages, a riverside walk, a new square, and footbridge. So looking a little closer, we're creating a centre. So we're creating a place that has a heart, which comprises of a lot of the things that I've just mentioned, but hotel, workspaces, retail, cafe, restaurants, offices, nursery, gym, all the things that you'd expect to find in a community with a heart. But how? So who's going to do the work? So in our design team, we've assembled what we think is a world-class team of experts in sustainable construction, green energy, low carbon mobility, and of course, brilliant architecture and design. So we've listed some of the architects involved, the likes of Periscope, Ash Sackler, Mole, Atelier 10, May, Material Cultures, Expedition, Archio, Algeride Pike, Rabble, Adam Richards. So I'm sure some of you have heard of many of those names. But how do we ensure that we stay on track? So in order to make sure that we stick to the ideals that we really believe in, we've developed this project blueprint. And in that, we've defined 20 key principles that guide the primary function of the blueprint is for the project team to understand and be kind of steeped in the key principles that have guided and will continue to guide the development of the Phoenix project. Now, there's a big list of 20 things. I'm not going to go through all of those, but I'll just very briefly go through a few of them in a little bit more depth, just to give you a bit of a clearer picture. So a 5-minute neighborhood. So there's another view there of the center. So the idea is that a 5-minute neighborhood is one where everything you might need on a daily basis in order to live, work, play is within a short walk. And community life is at the heart of everything. So it enables people to share facilities, share spaces, have access to workspaces and studios, grow food, eat well, exercise and thrive, not just to get by. Another one of our principles is the principle of super green. So greenery that coexists with the built environment. It's not just softening the buildings, but it provides colour and texture, and as well as enhancing biodiversity, providing a space for wildlife and for residents to grow food. Obviously, roofscapes, green roofs will add to this element of super green, but there's huge competition for our roofs. The roofs they'll have to work hard for us on this development. So there'll be a competition for water capture, green roofs, as green roof amenities, and as well as for energy generation. Another of our blueprint principles is that of bike culture. So we're developing a master plan in which the streets are designed to prioritise and enable cycling as the most desirable way to get around. So lots of bike parking, new cycle connections to the wider town, and creating streets that you're not afraid to cycle through. Another of our blueprint principles is shared living. So the Phoenix will be a communal and convivial neighbourhood built around a culture of sharing. We hope to encourage social interaction between people of all ages. In practice, this works in many ways through the sharing of physical space and amenities such as gardens, rooftop allotments, electric vehicles and facilities, laundrettes, co-working hubs, and beautiful public spaces. One of our other principles is this idea of raw and craft. So it's both a philosophy, so it's a way of thinking about homes, and it's also a practical methodology for designing, manufacturing, and finishing homes. It's grounded in the idea that homes, they should be fundamentally well-made, strong, resilient, and robust, with materials of outstanding quality that can be left raw if you so desire. The materials are not only low carbon, but with good maintenance, they'll be long lasting and they'll age with grace. The craft element speaks to the capacity for homes to be customized internally and externally by the occupants according to their own taste and budget. In terms of building fabric, now the list of architects that I mentioned and designers and engineers, so the principles that I'm about to discuss, they're embedded within the essence of every design decision at every level, because that's the pedigree of the design and engineering team. So these concepts of passive design, so solar gain, shading features like shutters, orientation and building form, whole life carbon assessment. The whole life carbon is used as an iterative part of the design process in order to optimize the relationship between material choice and performance in terms of energy efficiency. And this is informed by dynamic thermal modeling and fed into embodied carbon metrics. And green infrastructure, so the use of greenery for cooling, air infiltration, biophilia. So there'll be generous balconies, trellises, green walls, roofs, etc. And thermal mass and conductivity. So in order to minimize thermal conductivity, we'll be specifying new values that approach passive house standard, and we'll make sure that there's significant thermal mass optimized for energy efficiency and thermal buffering. And obviously air infiltration, we'll be building and designing highly airtight buildings in order to minimize heat loss. And so materials, the construction, the materials used in the construction and the construction methods that we'll adopt here, we recognize they have a big effect on our total development carbon footprint. And so the way we approach these issues around material usage and construction methods has been to follow these kind of guidelines, this sort of process that I'm about to go through. So in terms of reuse, reclaim, and local. So we'll start with where we are. So we started to look at where we are as a starting place. And to steal a phrase from Duncan Baker Brown, which we love, there's this phrase of mining the Anthropocene. So we look at what we've got already, and then we start to look concentrically outwards from our site to assess what's available to us. And we work on the following materials principles. So this is what drives our decisions underpinning the material selection and the construction methodologies that we use. So the reduce, reuse, recycle. And then once we've been through that, we then go, is it low, zero, or negative carbon? And then we go through our human nature principles of building design and raw and craft. So in terms of reduce, reuse, recycle, so when we're looking at the building stock, the place we started is that the first thing is, how do we deal with what we've got already? What do we do with what's here? And starting from the principle that the most sustainable building is probably the one that's already there. So we've carried out high-level investigation to ascertain which buildings are fit to retain and refurbish or add to, which ones were best to be deconstructed or reconstructed, and which should be removed from site for recycling. So following an initial audit of the existing building stock in terms of their condition, materials, viability, and how much life is left in them, we decided we're retaining 4 structures on the site. So through a process of creative adaptation, we're breathing life into 3 new heritage structures, which are existing on site. So this is a wireframe drawing of the Every iron and steel works, the foundry building that is on site, which is a historically significant ironworks which is the site where a lot of the decorative ironworks that are seen on the south coast, Brighton Pier, lots of the Sussex train stations, was all forged in these buildings. So we're keeping those because they fulfil all those criteria. And we reckon that we've done a brief calculation that we think that just by retaining these three structures and a fourth structure, which is an office block, which is where I happen to be speaking to you from right now, we just very, very briefly, we reckon that just the act of not knocking those buildings down has saved 1,800 tonnes of embodied carbon. So it's not an insignificant decision. So after we've got through to the next phase, we look at what to reclaim. So we'll be dismantling, not demolishing. So we carry out we will carry out a very detailed pre-demolition audit in order to create a resource management plan that allows us to facilitate careful deconstruction in order to create a source book for our architects, which will go in some way to define a palette of available materials and structures that they can use and incorporate in their designs. For instance, one of the buildings that we were hoping to keep was the Foundry Gallery, which we were going to use it as an event space, but the audit has turned up that it's actually not in particularly good condition, but the roof trusses are. So the architects that are designing a new event space are doing what they can to incorporate those trusses in the design of the new event space. And in terms of recycling, so we are committed, obviously, so we've within all of the aggregate that is that arises from the demolition works, we reckon quite simply we're pretty sure that we can reuse at least 95% of that on site. And what we can't use on site, we're hoping that we might be able to recycle some of it into other materials processes. For instance, I don't know if any of you are familiar with the Kinetech brick system, which is shown in the next photograph. We've been having conversations with those about potentially reconstituting crushed construction aggregate into an unfired brick product. I'll just show that as an example. Other recycled, obviously, any sheet piling or rebar that we use, we'll hope that will be. So we're looking at a sheet piling product called Eco Sheet Pile Plus, which is a very green steel sheet piling product, as well as the green rebar. And we're looking at chem-free concrete solutions, as well as the potential for possibly using fly ash from energy from waste plant within the concrete. But these are things that are under examination at the moment. So the next step in our process is to start, when we start looking at the materials that we do use, we're prioritizing the use of natural materials, things like hemp fiber insulation. Hempcrete will feature quite heavily on the in the construction. There's space for rammed earth, rammed chalk, timber, flint, all these natural materials that require less processing and that can enhance the natural environment and have lower associated embodied carbon. We will be prioritising timber as our primary construction material, as it's inherently sustainable, as we all know, and it performs structurally as well as any other building material and can do the same job. And it's also inherently more amenable to disassembly at the end of its life if it's designed for such. I'm just very aware of the time. I'm going to fire through now.
Two minutes, if you could, Andy.
Absolutely.
Thanks.
So within our build and design process, build and design is a process of deep collaboration where we look at the buildability of things before we commit to detailed design. So we've undertaken an investigation looking at one of the designs. So one of the designs we're looking at is a courtyard block in the style of Jan Gehl. Here we can see it from looking at it from the river. We looked at this as one of the most complicated blocks that we've got, and we figure if we can work out how you do this, within our principles, then we can do it anywhere on the site. So the process was to look at the construction methodology and whether we can build it all out of timber. So what we came up with is a modern method of construction system utilizing probably CLT and glulam structural structure, in which we can infill the external wall sections with wall cassettes, which we'll make in a factory on site ourselves, predominantly looking at Sussex grown timber as the structure for that. So obviously the engineered timber will come from Northern Europe, but the wall cassette panels will be something that we'll make ourselves in our own factory on site. This will allow us to utilise Sussex timber and natural products, and also it will benefit the local economy because there'll be jobs that come along with that, and it will allow us to maintain and keep a close hold on our principles that I've outlined in the earlier part of the talk. Just as a last thing, if we look at this, here's the wall section that we're thinking. So just to run through that really quickly. So there's a lining board. Battens will be Sussex timber. So the lining board, we're speaking to Indie Nature, who I think might be on this call. They've got a hemp fibre product, which hopefully will be available by the time we go to build. The timber will be, or the battening and stud work will be from timber grown in Sussex. The hemp fibre insulation possibly, or wood fibre insulation, and hempcrete as an internal layer to create thermal mass. And all of that will be manufactured on site and installed with the mass timber system. And here we can see the way that it fits together, and the flexibility of that means that the internal and the external finishes can be anything we want it to be. So the right hand picture is a picture of the vernacular in Lewes, and we're not suggesting that it will be as mixed as the picture as the middle slide, but the flexibility is there inside and outside for any future or rain screen or cladding systems. So there we go. Sorry for rushing through the last couple of slides of that. Thank you very much.
Thanks, Andy. That's fantastic. So you can sign up to a newsletter from Human Nature. So I've done that, and get updates into your inbox, what's happening down there. We will arrange a site visit. So it's a convenient moment, sometime maybe towards the summertime. So keep an eye on that. And what a fantastic development to be involved with. And thanks ever so much, Andy, for telling us all about it. So it was quite a whistle-stop tour. It's fairly full on. So no doubt there are a few questions. So I'm going to ask, it's that usual thing, we're running a bit tight on time. So I'm going to ask you, Andy, if you can have a look at the Q&A and respond to the questions there. And maybe we'll come back to you and have time for one or two questions in discussion with Avtar later. But now we've managed to find Avtar again. He's logged back in. So all being well, and the gremlins have been put to bed, we can ask Avtar to share his screen. And thank you very much. We look forward to your presentation. Thank you.
Simon, thank you very much, and apologies to everyone. Just as that video started, I just got kicked out of the session, so I do apologise. And Andy, thanks for stepping in. So welcome everybody. I've got a working title called Bio-Based Products and Formaldehyde-Free Binders. The reason why it's a working title, I think I set this title about 3 months ago, and things have changed subsequently. And having listened to some of the presentations, I've modified some of my slides accordingly. Hopefully there's something for everybody within my presentation. I do have a couple of slides with some chemistry on, but it's again with light touch chemistry. Just picking up on what Nicola Carslaw said, I'm not going to talk about energy reduction in my presentation, but my presentation does connect with Nicola's talk, but also it connects with Andy's talk as well, especially towards the end, looking at the GEL products. So I just want to start off with the big picture and how do I see the big picture? So I'm Deputy Director of Green Chemistry Centre of Excellence. Green chemistry is simply easiest way to describe it is doing chemistry that's good for me, it's good for you, it's good for our environment, and it's good for our planet. And the reason for that is, as we all know, we only have one planet, we only have one resource. And this resource is under stress as we go from 7.5 billion today to approximately 10 billion by the end of the century. That's going to be commensurate with increasing industrialization, increasing urbanization, and hence increasing construction. And chemistry is at the heart of construction. And here in the middle, okay, I've got a picture of how a lot of the general public perceive the chemical industry. It's dirty, polluting, not very nice. And often we forget all the benefits that chemistry provides us. For example, wherever we're sat listening to the presentation, the articles that we're using, the office space that we're sitting in, the chair, sofa, whatever, at the heart of that is chemistry. Chemistry is the heart of the production of those materials. But we want to move into this cleaner, greener world on the right-hand side where, first of all, no one recognizes it's a chemical factory because we're using the resource properly, we're using it safely, we're not using crude oil, which is often the problem as our resource. We're growing our resource essentially here over on the right-hand side in this field, or we're using waste as a resource which goes into this chemical factory. It's in tune with the local town. So in terms of sustainable development, we've got a factory that is in tune with its community, with the environment, with the planet, but also it fits in to the 17 Sustainable Development Goals. What we mustn't do as we go from left to right in terms of chemistry, we really shouldn't mirror our past, and that's a key message. My second take-home message is that we live in a linear economy. We live in a linear society where we take from Mother Earth, and we take quite a lot at the moment. Our global material footprint is approximately 90 billion tons, and that's only going to grow as we get increasing population. Our per capita footprint at the moment is about 11 tons, but that's not equitable all over the world. If you live in the UAE or in the States, you're probably using about 25 tons per year. If you're from Bangladesh, you're probably using about 1.5 to 2 tons per year. In terms of making, UK, we've been absolutely brilliant, as is Europe. We've been absolutely brilliant at making things. And often when we make things, it involves a lot of synthetic chemicals because crude oil is at the heart of a lot of things that we make. Absolutely, the stuff that we make, we then go and use. And a lot of the use materials, this is where construction comes in, this is where healthy building comes in. But also as society becomes more affluent, so Nick partially mentioned consumerism in her slide, the consumer class, that definition is given to people who have more than $10 per day to live on. That's going to increase from approximately 3.5 billion to 5.6 to 6 billion by the end of the decade. So there are going to be more articles and goods in use. And unfortunately, end of life, a lot of the material that we use ends up in waste or landfill, and we abuse the resource that we take from Mother Earth. So that's the concept of linear economy. We're moving from cradle to grave. And I always say that often we just need to reflect on what we're doing. And I always use one of Mahatma Gandhi's quotes, in the earth provides enough to satisfy every person's need, I would say, but not every person's greed. So the future is we've got to live in a circular economy. And I know Andy mentioned circular economy towards the end of his talk. And this also fits in with SDG 12, responsible consumption and production. So doing more with less, using waste as a resource, cradle to cradle thinking. So the material that we abuse at the end, we've got to now start to think of that as a resource. So I've got some case studies that I want to go through very quickly in my presentation. One is bioboards. The second one is switchable adhesives for carpet tiles. I'm lightly going to touch on PVC replacements, and then I'm going to look at waste paper as a potential adhesive. So in terms of my first case study, bioadhesives from waste biomass, biosilicates to bioboards. This is in the chat. There's been a lot of discussion about timber, engineered materials, chipboard, oriented strand board, etc. Wood panelling in the UK is a major industry. There's a lot of tonnage associated with wood panelling, and it's how it's constructed. Obviously, we're using natural wood, we're using chips, flakes, etc. But it's that binding together of those chips which is the problem. And the problem there is literally the use of the chemicals that are used as binders. So we've got urea, formaldehyde, phenol, formaldehyde, and isocyanates. They're okay when they're cured, but it's when they're not cured, and then they tend to volatilize out into the atmosphere. And as Nicola mentioned, that formaldehyde certainly is a carcinogenic, so we need to prevent that. So what's our solution? Our solution is to use agricultural straws. There's no shortage of agricultural straws in the UK. The UK generates approximately 12 million tonnes of straw every year, and we actually export about 3 million tonnes of straw over to Northern Europe. Wheat straw, there's probably about 3 to 3.5 million tonnes of wheat straw in circulation, and that's often used for animal bedding, but also used for overwintering of carrots. Carrots are best left in the ground and covered with a matting or layer of straw. So we don't want to use natural wood. We're going to use agricultural straws as our aggregate or main component. We're not going to use urea or formaldehyde or phenol or isocyanates. And we're going to use an aqueous silicate solution as our binder. And we're going to tweak the formulation by using materials from food waste, which are no longer edible or which can no longer go back into the food supply chain. This is a picture of Jenny Dodson. So that's her collecting wheat straw several summers ago. And the whole concept here is we've got an agricultural biomass on the left-hand side, and we want to move over to the right-hand side and create structural furniture or structural boards. Yeah. And if you can see me, I'm just holding up an example of what we've made as a result of this project. So in terms of the technology, what's really interesting about this project, we take straw, and most of the straw at the moment currently goes to generate renewable power at Ely Power Station. They generate considerable amounts of ash as a waste or byproduct as a result of producing renewable power. We take the ash and we actually leach out soluble biosilicated adhesives from the waste ash. We don't actually add the ash into our material. Okay, it's the silicates that we leach out. We take our straw and we take the straw and we actually de-wax the straw. If you take 2 strands of straw, there's a hydrophobic coating on the outside, and that stops any water-based glue from making them stick effectively. So we take the layer of wax off. So essentially we have wax-free straw. We add our biosilicated adhesive. We add a bit of food waste in there as a hardener, and we make these bioboards here on the right-hand side. The nice thing about this is there's additional benefit to this project in that the biosilicated adhesive that we have, not only can we use it as an adhesive, but this biosilicate solution also lends itself to a whole set of silicate products on the right-hand side. I mentioned that the straw, we extract the wax. The wax we extract as a natural coating, and that natural coating that has been extracted now gets used in cosmetic applications and in food additives. So we're adding to the concept of taking waste as a resource and not only making bioboards from it, but also valorizing this a lot further. So this was our concept board, which I'm just holding up if everybody can see that. That's what we started from in the laboratory, and we ended up with making a full-size kitchen cabinet door. So I'm just going to hold this in front of my face to give you an idea that it's sort of from bench to reality. So that's example 1. Just moving on to example 2, and that's the issue with carpet tiles. Most houses in the UK have carpets or carpet tiles. I know there's a move towards wooden flooring. The issue with carpet tiles is I've got this sort of image here, a cross section of a carpet tile. This essentially is 100% crude oil. It's crude oil just in the form of a carpet tile. So we've taken crude oil and we've processed it and we've manufactured it into this material. And a carpet tile is brilliant. Okay? They're built to last. But because they're built to last, then that has a problem in the end of life. Carpet tiles generally used to go to landfill, but now are predominantly incinerated because of their high calorific value. Because as I said earlier, it is just crude oil, but in a different shape, in a different form. So we need to stop this from happening. Okay, so we're going to stop that process, this linear process of cradle to grave, and we want to develop a switchable adhesive which allows carpets to be recycled and to be reused. So that's the technology that we've developed, a switchable adhesive layer that stops carpets then going to landfill, and we develop this circular process of keeping the resource in the loop. So the problem here is it's this butadiene styrene latex that's used when we fix the face layer to the bitumen base layer. That's very, very strong, and that prevents the recycling of a carpet. So the technology that we've used, we've actually used waste starch. There's no shortage of waste starch. We've modified waste starch very, very slightly. So the modification here is in blue. And we've formulated our switchable adhesive, which we've then applied. So this is a cross section here of a carpet tile, and this sort of thin white line that you can see, that is the layer of the glue that's between the bitumen base layer and the face fibre. And this has undergone all the tests that industry requires. So for example, how easy is it to pull the fibres off the face fibre? How do they perform against the caster chair test? And that's just as if you sat in a chair, as we shuffle around, move around, how does the carpet face up to that sort of damage? Importantly, flammability in our adhesive, we have no additional flame retardant. So again, that's a real plus point. And the additional plus point is that our adhesive is switchable. So by switchable, what do I mean? So in its working life, okay, it's in its bonding phase. When it comes to end of life, we take the carpet, we put it into a tumble dryer, set at 130 degrees centigrade, approximately 30% relative humidity. And under those conditions, the glue debonds. It switches from bonding to non-bonding, which means that the face fibre goes in one way and the base layer goes in the other way. Both are washed, re-yarned, and then brought back together. So again, just in terms of show and tell, here's an actual 60 by 60 carpet tile based on our technology. Okay, so that's just a picture of the carpet. Very quickly, just a couple of slides on this one. This is vinyl flooring, and we were tasked with the project of can we go PVC free, but importantly, can we go phthalate free? So phthalates, again, are endocrine disruptors and a major problem within healthy buildings. So we were tasked to make a green formulation. So our green formulation was based on, again, waste starch, but also waste oils. So there's no shortage of waste oils circulating within the UK, and especially bio-based waste oils. And we've got technology to convert the bio-based waste oils into epoxy oils. And I know the construction industry uses a vast amount of epoxy resins and epoxy oils. So we've generated waste starch, combined those with epoxy oils, with another cross-linker, which is acidic. And in doing so, we've been able to generate mimics that are PVC-free and phthalate-free as an alternative to vinyl flooring. Okay, so that's what this is just showing. This is a slide copied over again. And then the final example is waste paper. And again, there's no shortage of waste paper that's circulating within the UK. It's a huge myth that paper can be recycled up to 5 to 7 times, and often that myth is spread across the internet. When you talk to the paper industry, waste paper can only be recycled max 3 times. The fibres, the aspect ratio of the fibre gets too short. You get to a certain point where the fibres are too small for any sort of meaningful bonding to remake paper. So this particular project that we carried out, we took waste paper. This was just office paper. We shredded the paper, and if you think of your microwave at home, we've got similar microwaves, but obviously more powerful. We put waste paper into a microwave, and essentially we pyrolyzed the waste paper. So the pyrolysis process simply means converting the waste paper into a char. That's what pyrolysis effectively does. It carbonizes the material. But when you pyrolyze, not only do you make char, you also create bio-oil. That's here at the bottom. And the concept was to take the bio-oil, and it's a complex mixture. We don't want to purify it. The more we purify it, the more steps we generate, and the more costly the whole operation becomes. So I challenged my student, whose name is Neil. I challenged Neil to do something with the bio-oil. I said, I don't want you to purify it. That's what we do as chemists. We tend to over-purify, we tend to over-engineer. So I asked him to use the oil as it was. So what Neil did was he took a drop of this oil and he placed it between 2 aluminium plates, and he measured essentially the strength or the force that's required to pull the 2 plates apart. And that's the challenge that was given to Neil. So if I go on to the next slide, I can take you through this. So these 2 aluminium plates, 5 centimeters by 5 centimeters. We've put a drop of the oil that's come from the pyrolysis of waste paper. Okay, and then we've sealed the 2 plates together. We've cured the plates, and essentially the 2 plates now are being held within the jaws of an Instron machine. They're going to try and pull the 2 plates apart. And Neil did that, and as a good scientist, he got some data, and he said to me, after I look at this data, it's wonderful. We reach a maximum tensile strength of 2,300 newtons. And I said to him, well, that's brilliant, but what does it really mean? Can you tell me slightly differently, or can you express that number slightly differently? And this is Neil's solvite moment. So you know, it's a concept of so what? You've taken waste paper, you've made this bio-oil, you've put a drop of it between 2 aluminium plates, you've got a bio-based adhesive, so what? So I'm just going to run this video to show Neil's so what moment. And this is Neil's solvite moment. So this is Neil, and he's been held together here. Okay, this is 2 aluminium plates held with a drop of his glue, and we're going to lift Neil off the ground. I'm going to turn the sound down because there is a bit of swearing in here. So this is us beginning to lift Neil. He's looking very worried. I'd be worried as well. Neil weighs, and he doesn't mind me telling you this, he weighs about 15 stones. And as we're sort of lifting him off the ground, he's now off the ground. He's feeling a bit more comfortable. And we're going to spin him around, and he's going to wave to us nervously. And that's the way of explaining what 2,300 newtons represents from 1 drop of oil that's come from waste paper as a result of that being pyrolyzed. So that was my essentially my last slide, just taking you through some examples that can be used within healthy buildings. But again, importantly, it's where we don't lose the sight, where we don't lose sight of the big picture, and that big picture is mitigating climate change and doing good chemistry, good science that's good for you, good for me, good for our environment, and good for our planet. So on that note, thank you for listening.
Super, thanks, Avatar. That's a really fascinating look into what's coming, which is really exciting. So exciting that you guys are working on things like this. So we've got not a huge amount of time, about 5 minutes to take a few questions. There's a couple of nice questions coming from Barbara Jones. I don't know if we can ask Barbara to unmute and ask her questions. Can we do that, guys?
Do you want me to take? Do you want me to answer, Bob? Yeah.
Can you hear me?
Yeah, we can. Thanks, Barbara. How are you doing?
I'm all right, thanks. Very interesting so far.
Thank you.
Avatar, I'm interested in what you're using the straw for, because I work a lot with straw for house building and panels, etc. And you said at the beginning that you stripped the wax off it. I wondered how you did that, because surely that is a chemical process in itself.
Yeah, absolutely. As is the making of the bioboard is a chemical process. So the way we strip wax, we do it two ways, Barbara. We either use alcohol, ethanol, so bioethanol, okay, or we use carbon dioxide. Carbon dioxide is an absolutely brilliant solvent, despite all its bad press. If you drink decaffeinated coffee, there are two ways to decaffeinate coffee. You either use the Swiss hot water process, or it's decaffeinated on industrial scale using supercritical carbon dioxide. The benefits of CO2 is that you don't get any residue of solvent left inside your wax. So we do it both ways. So both ways are essentially clean and green. The CO2 method, we keep recirculating the CO2. We pressurize it, we compress it, we make it supercritical. It goes through our straw, we pick up the wax, we depressurize, the CO2 goes back to gas, repressurize, etc. And the ethanol one is just boiling in ethanol, filtering and evaporating off the ethanol. The ethanol again can be recycled and reused in that process. So hopefully that answers your question.
Yeah, great. So what do you do with the wax after you've taken it off?
Yeah, so that gets sent to cosmetic industries. So it's a hydrophobic coating. So cosmetic industries are using it in their products. But also, if I want to, I can put it back on here as a surface coating and make this water repellent. It's also been used in textiles industries as a hydrophobic coating on fabrics as we move away from perfluorinated compounds, which again is a big problematic area.
Great, that sounds brilliant. Thanks very much.
Thank you.
And Barbara, you had one more question, which was about, are you still there? Are you still live?
Yeah, I'm still here.
So you asked a question about the government and indoor air quality. So you said, is there any indication that government or the construction industry are at all concerned about indoor air quality?
Yes.
What do you say to that, Avatar?
It's probably a question more for Nick. Nick is more an expert on indoor air quality than I am. Yeah, certainly, absolutely. The government is worried about air quality in general, overall. Air quality emissions have been declining over the last 5 to 7 years. In their data, which I have seen the data, I can't at the moment remember how much of that is associated with healthy buildings. Often they've just been looking at air quality generally. So this is part of Michael Gove's 25-year environment plan. There's some data now that's coming out of that. But I would ask Nick being the expert. Yeah, and I would just add, Barbara, that we've got some speakers after the break who'll be looking at new British standards and for indoor air quality and VOCs. So there is definitely a lot of work going on in this field. So there's a few other questions. We had a question about paints. So I would say this, wouldn't I? But all of the ASPP members, our Paints and Finishes group and paints members are selling healthy products. So do have a look at our website, see all of our
members there. Get in touch with them if you want to talk about healthy paints and finishes. Okay, well, look, it's been a fascinating first session. So what we're going to do now, I've got one more question. So from Zoe. So what are the barriers to getting these innovations into mainstream manufacture? That's quite a big question.
Yeah, and if there are any manufacturers listening, you probably know what I'm going to say. The challenge that we have of moving from petroleum-based to bio-based is often cost, performance. The quicker sustainability moves higher up the agenda within strategy, the better. But also we've got to have a bit of time and patience. Often manufacturers are looking for the solution today. And what you've got to realize is that we're actually competing with a 100-year-old oil industry and the advances that have been made there, where production times have been shortened. Okay? And that's one of the issues that we'll have. The board that I've mentioned here, absolutely sustainability, very, very high, very, very strong. Okay. And what I forgot to mention was this is also flame proof. This is encased essentially in silica or silicate, which is glass. But because it's a water-based binder, the drying time is much, much longer. So again, it's having that patience. So those are the barriers to what I would say high volume materials. Okay? The barrier to entry to low volume, high niche products is probably a lot lower. And often we get a lot of calls from architects and designers who want to put our materials into concept homes and concept buildings. So that's a part of an answer to a very much longer debate.
Yes, yeah, we could spend the rest of the day talking that through, couldn't we? All right, folks. So what we've got now is just a 5-minute comfort break. So get up, shake a leg or two, make a cup of tea, and then if you can come back for past, so you're going to have to work pretty quick. And then we've got a breakout session. So we're just going to pop you into a randomly selected breakout room, and then it's time for just a bit of a chat over your cup of tea and networking with folks who are in your room, and a bit of light-hearted conversation. So we'll see you in 4 minutes' time. So welcome back, everybody. I hope that's long enough to make a swift cup of tea. So I'm just looking through the list, Richard. I can't see any of our speakers are here for the next session. But we'll keep an eye on them as they come through. But what we're going to do now is to bounce you into a breakout room. Either you'll know the people really, really well, which often happens, and you'll end up talking about something completely different, or you won't have met them at all. So it's going to be a random selection. There's no logic here, apart from illogical logic, if there is such a thing. And so if you're sitting comfortably, we're going to catapult you into a selection of breakout rooms. And so we've got 20 minutes in the breakout room, and then we'll be back at 10 to for our next session.
We're just trying to find the breakout room option, actually, Simon. I think Larry is the host. Are you able to do that? Interesting.
Do I need to make you the host? No, I can't, can I? Because Larry's the host.
No, Larry's the host.
Are you there, Larry?
Usually it would be a little option. He says he doesn't have that option either, which is interesting.
Oh.
Let me reclaim. Interesting.
Should we play charades?
We perhaps might have or a bit more Q&A for a slightly longer break, Simon, I'm afraid. We seem to have lost the breakout room option, which is a new one on me, I must admit.
How peculiar.
Apologies.
Yeah, no problem. Well, just enjoy your cup of tea for the moment, and
we'll see what we can do.
Yeah, I mean, if it's not there, it's not there. It's not going to suddenly pop back in, is it? I don't suppose. Maybe with a...
Interesting.
Okay. Well, it's charades then.
Are there any more questions?
Yeah, we've got quite a few questions come through. So
okay. Well, we can unmute some of our and get a bit of a conversation going.
Yeah, so there's a few questions that have been answered. So thank you for those who've been answered. So we've got Michelle Jill, who's been mentioning Earthborn Paints, great company, great product. Hunish has asked, what's the best way to get involved with our new working groups? And so, yeah, just drop us a line. So Richard has responded to that, and just get in touch. So we had a question in from Ed Jeffries, which was, what is the current likelihood of the project being completed as desired, and what are the biggest obstacles remaining? So Andy, since you're there, and if you've finished your biscuit, accompanying that your nice cup of tea, maybe you can speak to that and fill in for us.
Yeah, it was. So can you just remind me the question? What the full question? It was about barriers. What was the first bit?
What's the current likelihood of the project being completed as desired? And then what are the biggest obstacles remaining?
Yeah. Okay, so so the stage that we're at is the site has planning, but the previous scheme is suboptimal, shall we say? So we never had any intention. In fact, no one could ever have built the previous scheme. It would never have financed itself. So our plan is an entirely new submission. We submit in May. The planning authority we've been in, obviously in a scheme of this size, we've been in conversations with the planning authority for the last year. So they've got a really close idea of what it is we're planning. The biggest barriers that they're putting up at the moment are, unsurprisingly, around transport and parking. Okay. Because we want to design such that there isn't a parking space for every house. There isn't a parking, there isn't on-street parking outside your house for anyone. It's not that kind of neighbourhood. That's something that they're kind of struggling to get their head around, that being all right. So they're not saying it's not a no, but it's such a different way of looking at parking that it's taken some time to get that message across. So the offering is that there'll be obviously some blue badge parking on street, a certain number of on-street parking spaces, but we're providing a co-mobility hub, which is effectively built as a car park, but it's got provision for 100% electric charging points in the fullness of time. It's got an electric car club, an electric bike and cargo bike rental facility. It's got last mile delivery service in order to try and reduce traffic movements through the development. And so the expectation, what we believe is that the experience for people living there will be that they won't miss not having a car. They'll have the best EV car club you've ever seen, so that there's a car available for them, fully charged at all times, so that they don't need to, and they won't miss owning a car. But that's a difficult shift for English middle class people, effectively, imagining that they can live with it. So, but it's not really the custom. So we did a design festival where we had a design event over the summer, where over 3,500 people came to look at the displays that we put up, and not many of the people that are prospective residents actually had a problem with that. It's the planning authority have more of a problem with it than the people that are likely to live here. Yeah, it's quite radical, isn't it? I suppose. Yeah. But in terms of the delivery, there's the planning is the planning consent. We're not imagining it will be a problem, because politically it's quite important that this site gets developed. Now it's been a brownfield site under development for about 10 years, right. And so politically it would be a big deal if it didn't go ahead. Yeah. But in terms of the barriers, there's I don't want to say there are people queuing up, but every day there are new people wanting to invest in the scheme. So the big barrier is the planning, and the barrier to planning is the transport. Well, good luck with that. Let's hope they see sense. Let's hope so. Yeah. All right. Thank you. So we've got Richard's pointed out there's another question from Ed Jeffries for Avatar. So maybe we can unmute Ed and take his question.
Simon, could you do that, please? I'm lost my powers.
Yeah, I'm sorry about that. So I just unmuted you, Ed.
Cool. Can you hear me?
We can, loud and clear. Yeah.
Fantastic. My question was it was at the very end with one of your boards. You said that they were coated in silica, and I wondered if that would affect their breathability or sort of permeability in terms of if they were used in a household. Is that going to?
Yeah, no, it's a good question, Ed. they're not literally coated in silica, just way of describing the product. So I use a biosilicate binder. So biosilicate or silica is essentially glass, and they're coated in glass. The board here, this is developed to P3 standard. So for P3 standard, it's got to have no more than 14% swelling. This is breathable. So essentially, this is a living board. It's certainly not at P1. I always describe P1 standards as rich tea biscuit. When you dunk that into tea, it just disperses. So this is more of what I would say, a very strong Weetabix, to put it that way. So that's what we're achieving. Yes, it is breathable. And sorry if I misled you by saying the whole thing is encased in glass. Hope that answers your question.
No, not at all. That's good. Thank you for the answer.
Okay, thanks now, Ed. So we've got another question in from Chloe from Natural Building Systems. Chloe, if I take you off mute, I'm wondering if you can ask your question.
Hi, can you hear me?
Hi there. Yeah, loud and clear, thank you.
Yeah, it's been really interesting. And my question was for Avatar mainly, just around the board products you're developing. Obviously, the challenge to getting these adopted is being able to scale the production of them. So I wondered if you had any plans for your products to go into scale production, or any advice for how others could navigate that journey.
Yeah, so the case study on the bioboards, that's a fairly old case study. It was part of a DEFRA project. So we had the farmers at one end trying to get more value from their resource, and then we had a commercial company at the other end, that company being B&Q. So there's no secret behind all the companies who are involved in a publicly funded project. We did make a prototype board, which was supposed to be for kitchen cabinet doors, and the product itself was to be a replacement for MDF and chipboard. The issue is that chipboard, extremely cheap, and it's those challenges of, as I said earlier, Chloe, it's the challenges of meeting high volume, fast moving goods. That's one of the issues that we have. So in terms of navigating the journey, it's almost navigating low volume niche products, niche applications, or less challenging applications. So although I've said this is for P3 standard, if this was P1, I could fit this into any indoor area as long as it doesn't come anywhere near water. So I could have this as shelving if I wanted to, and that would gain consumer acceptance. But the move forward is more and more people, and there's this public push to move towards sustainability. I think the bigger challenge and the bigger conversation to have is, what's understood by sustainability? How does the public understand sustainability? And I'm really mindful that we don't go into greenwashing. So I could easily, there's loads and loads of products of this type out there, but if they're using a formaldehyde or isocyanate binder, then they're actually greenwashing, because they're actually selling you the fact that this is wood-free, and they're hiding the killer bit, and that's the chemicals that are put there to hold it together. But it's one of those much longer conversations, Chloe, which I'm happy to have offline.
Great, thank you.
Great, thanks, guys. So I'm afraid that technology has beaten us. So it's a bit of a mystery why we can't use the breakout room function, because we have done on numerous occasions in the past. So I don't know whether this is a new version or something, so I'm sorry about that, because that's usually quite a fun session. But what I think we should do, we're 5 minutes ahead of ourselves, which is unheard of. But I think what we're going to do is just push on with the next session. So I'm going to ask David Kieff, who's Managing Director at EFT, to unmute and to put your video on, David, and then ask and then share your screen. And there we go, smashing. Thank you very much. Thank you very much for joining us.
You're welcome, pleased to be here.
Smashing. So over to you then. Thank you.
Thanks very much, Simon, and good afternoon, everybody. One of the reasons I'm here today is to tell a little bit of a story of where we've come from, where we're going, where we're heading, and how we see the holistic approach to well-being in the built environment. A number of years ago, I was lucky enough to be the president of our professional body, Engineering and Excellence in Britain, in 2016, 17 and 18. And during that time, I spent an extensive amount of time traveling the country, talking to BISRIA, BRE, lots of other building research environments. I was in a presentation in the brewery in London, where there was a presentation in relation to health and well-being in the built environment. It was very apparent from that presentation that there were growing issues in correlation of respiratory problems in relation to our buildings becoming so-called healthier, or supposedly healthier, I should say. A lot of that was to do with energy efficiency. And what we could see was a correlating timeline of buildings becoming more insulated in relation to more respiratory problems and problems with people's asthmas and respiratory problems growing year on year and generation on generation. And there was definitely a line where you could see that the improvement of one to the detriment of the other. So back in 2016-17, I'd identified that obviously with BISRIA, and made it a challenge to myself and my business to try and identify how we could try and change that, especially being a building services engineer in relation to the services that we design, supply, install and maintain. Having undertaken quite a bit of research, it was quite obvious that the World Health Organization, CIBSE, BISRIA, others, all had their own take on holistic well-being. And it was very, very apparent on a worldwide basis that the standards and measurements were completely different. Sometimes different amounts, different quantities, different qualities, all sorts of things. So that there was no correlation between the information between people who were guiding the industry on a worldwide basis, UK, Europe included. So we set off to look with our internal consultants as to what that looked like, tabulated it all, looked at the problems and made it a mission to try and rectify it. And it's been a long story since then. So I'll flick through the presentation quite quickly, but to give you an overview of where we came from and the reason why we're doing it. Our business, Engineering for the Future Limited, is what it's actually called, cut down to EFT Consult. We work globally. We work with United Smart Cities. We work with people right across the world, and also try and get information that's not just UK centric, but world and global centric, so that we can try and get some larger vision of what's going on elsewhere. And what we try to do is bring that experience to what we're doing here in the UK. There's a big reason why we're doing it. As you can see from that slide, the facts and the figures, 90% of our Europeans' time is spent indoors, which obviously is an issue. 3,000 new cases of occupational asthma diagnosed each year. 70% of workers say poor air quality makes them less productive. 66% fall in staff performance when distracted by noise. 1 in 10 cases of adult onset asthmas relate to the workplace, and 46 more minutes sleep at night for workers in well-lit offices. There's a lot of things there that happen in that environment, from particulate matter and lots of different things that happen in that environment that affect well-being in the built environment. The reasons why, obviously the unintended consequences of energy saving and decarbonisation. Well-being actually creates energy saving and decarbonisation as an automatic output, whereas the others on their own do not create well-being. So there's a growing concern over the impact and cost of ill health and pressures on public services. It's about improving the quality of building stock to meet the well-being needs of current and future generations. In Wales, we have something that's called the Wellbeing of Future Generations Act in 2015, which was quite a slow burner for a little while, but is a very well-respected piece of legislation, and is driving what we're trying to do is better for our future generations. So decisions we make today, looking at what the effects are in the future, and it's a very strong and very well-supported act at this moment in time. It's about investing in the future of the industry and providing a legacy, improve performance for occupants, increase cognitive function, productivity, reduction in fatigue, tiredness and stress, employee, tenant, customer retention and loyalty, improved indoor environmental qualities, and about an environment which occupants feel comfortable and valued. It's also about the attraction of new staff, the generation increase, generation changes. I'm a baby boomer, I'm around Generation Z now, but people are going and working for people these days where they feel valued, and that value is about their health and well-being while they're in work. So it's making a big change to the workplace that we work in. It's about excellence as a standard. I'm going to tell you the quick story of what happened. It's about health and well-being. We started off in having done our research. In December 2019, EFT Consult sponsored PAS 3003. I'm not sure how much you know what PAS is, but it's a publicly available specification that you can buy into and buy a copy of to be able to deliver your buildings in relation to a standard. What happened in 2019, we sponsored it. We had a lot of industry support right across industry across the UK from some of the highest professional bodies in the UK. We had an A-list of people who wanted to support us, and they all joined and assisted. So we set out to present and deliver that PAS. We sponsored it, and we actually led the steering group for the PAS. And then obviously we all know what happened in March 2020 with COVID, and obviously we were on hold a little while. What happened was during that period, in the first number of months of COVID, people became more aware of the environments they lived and worked in, and the effects that that had on themselves and their colleagues in the built environment. So what happened during the next 3 months, so from March, April, May, June, back in July then of 2021, the industry started talking to us in relation to, hang on a second, what you're doing with the PAS is far more important than that, and we'd like to take it straight into a British standard. So we discussed with British Standard, we discussed with the industry. They were very, very impressed with what we'd achieved to date. And we then took, through a process, took the PAS out of being a publicly available specification straight into what was created as a BS 40102. And that's about creating the code of practice for that you'll be able to say to somebody, these are the standards I want to meet. So that's a little bit about the history of the PAS. And it's actually creating a well-being measure, very similar to an EPC, but a well-being performance certificate in relation to the buildings we live and work in. It started with the idea, years of research, as I've already explained. We formulated the ideas and potential and solutions to create a better environment. 2019, we suggested to BSI with the PAS, a framework for a new standard. December 2019, a very short consultation. I'm not sure if you know what happens with the PAS. It has to go before British standards. They have to go to the members and they have to approve the process. What we proposed was one of the quickest processes ever undertaken by BSI for the agreement of the industry to support it. And then in March 2021, the importance of the PAS was notified and advanced it to a full British standard. As I say earlier, we went to look for an A-list of people that wanted to support this because we wanted everybody to work together. We didn't want to work in isolation. It was the mutual benefit, it was the benefit of our future generations. So these were some of the early takers: the Welsh Government, Central Government, Public Health England, some of the CIBSI, BISRIA, BRE, EMA, VISA. Some of those people there represent some of the largest organisations in the UK. And we're excited to be a part of the journey with the collaboration with BSI. BS 40102 will take a groundbreaking holistic approach to internal environmental qualities. It's a new standard which will drive the evaluation and guidance on subsequent improvements for buildings. And this isn't only on new build. As we know as a statistic, something like 80% of the buildings we'll be working and living in 2050 are already built. New build is quite a small component of what we do. So retrofit and facilities management is a big part of what we need to influence to make sure these buildings are healthy. And there's a lot of things happening post Grenville in relation to obviously how we operate, run, maintain the standards in our buildings, which will all be part of improvements for the future. So very shortly, and we had a meeting this morning, and in the next month or so, the draft BS 40102 will be out for public consultation, which I'm sure a number of you will be commenting on, following which we're hoping to have a BS 40102 out to the public in the end of Q2 this year. That document will be leading the industry. It'll be giving guidelines or parameters of 9 measures of health and well-being in the built environment. I don't want to talk about the details at the moment, but it's about circadian rhythms, it's about lighting, it's about particulate matter, it's about CO2, it's about oxygen depletion, it's about measuring internal air quality against external air quality, what's the best thing to do with ventilation strategies, and how we rectify the problems. It also includes the people themselves. Part of the process is actually undertaking a survey with the people living and working in the environments, and making sure that they understand what the effects are of what we're trying to achieve. With one of the businesses we did a consultation with, just undertaking the consultation, and the managing director spoke to me after it was done. The people themselves felt involved and felt that they were part of the process. And the trouble is at the moment is that with all the standards that we operate with, humans are not all the same. So if we have standard lighting levels, if we have standard lighting color, if we have standard ventilation, heat and cooling, everybody's different. So it's about individual control and individual ability to be a part of controlling your built environment. So a very important bit of legislation. The industry is watching very closely. We've also developed then a set of metering and monitoring platforms that meter and monitor where you are today. So that when you start improving, you can actually do your ESG reports and your reporting from our platform. And it'll actually show you decarbonisation, energy saving and well-being standard holistically as one component working together. So this can be white labelled and put onto existing BMS systems. It can be put onto your head end. It's not done to make lots of money during the process of the evaluation process. It's about getting the results and making sure that we all buy into well-being in the built environment. That was a very quick and potted overview, Simon, and I hope it gave you a little bit of a vision into it. And any questions, please ask.
Yeah, thanks ever so much, Dave. Appreciate that. So quite often with this type of thing, if you're reporting back to a client with some bad news around indoor air quality, quite often that's not very well received. So just as a point in case, we asked PPM, who are members of ours, to measure the indoor air quality at a previous conference back in the days when we could all gather in the same room.
Yeah.
And what we found was that at the beginning of day, the sensors were off the scale. And they thought, what's going on? Do we need to recalibrate everything? They checked everything twice, 3 times. And then we sort of realized gradually that it was the cleaning regime that was, being used at that time at UCL. And then through the day, you could see the dissipation as it gradually faded away. But this is quite a sensitive subject, isn't it?
It is. And to be honest, like you've just said, even our own building failed. Yeah, I'm not saying that we or anybody else are leading the way in their buildings. It's about making people understand where they are. Yeah, it's not about frightening people. The thing that's happening though is that I sit on a board of a professional body in London, and we owned a few insurance companies. And 6-7 years ago, we saw the first people in London sue their employers, sorry,
Really?
For the environment they were working in, and they won. Yeah, and that was about 7 years ago. Since then, I've given a few presentations to some insurance companies, and I wasn't aware that this is happening on a regular basis. Now, we've got 2 ways of dealing with that. We either try to ignore it and hope that we aren't the ones getting sued, or we try and get in front of the curve, because negligence is no defense, as you know. So if you get in front of the curve and start identifying what your problems are, put a rectification program in place, then you are actually protecting yourself, not leaving yourself open to be for attack. Especially in relation to, you take large landlords, social housing, 100 flats, maybe in one block, all the same, all will have the same ventilation problems, all will have the same problems with their health and well-being. Some unscrupulous company will come along, say, can we come into one of your flats, meter, monitor, measure, show it fails, and then be suing the landlord for every single flat. So this is not about frightening people, it's about being on their side. We can't penalise them for not doing it. So it's not about frightening the people in the environment. It's about making them a part of it and realise that the people that are looking after them are trying to improve it.
Yeah, I couldn't agree more with you. That's very well put. So you say that the new standard you think may come in the second quarter in this year.
It's out for public consultation in the very near future.
That's a lot of work, isn't it, in a short amount of time?
To be honest, it's my team, and we led the steering group, and we're part chairing the British Standard steering group is delivering this. It's an extensive amount of work. It's been a big investment by us. And the outcome for us, people ask me, you know, why have I done it? Well, one, I've got young children myself, and I want to improve the future generations for them, and that's very important to myself. But also the model that will happen is that everybody will be on the same path. People will start to look at, and I know Base and others have looked at, well, let's just make everything energy efficient. Yeah. Whoa, hang on a minute, spending £10,000 and putting a heat pump into a leaky building and doing these things in isolation isn't the answer. You've got to understand the whole thing holistically and do the right thing in stages. And people just putting a sticking plaster on, just by doing one of those items in isolation isn't the answer.
No.
So it's about people understanding the holistic approach of what you need to do to get to an end goal properly and spend that money and support that path properly for the industry. And that's what we're about, is making sure that everybody that's guiding the industry and leading what we're doing is doing the right thing in the right manner and understanding what those steps are. And we've created training programs for consultants to upgrade, to understand to this standard what it'll mean. So existing building services engineers can go on a CPD course and actually upgrade to what this actually means, and then they can deliver it. It's not us delivering it, it's the industry delivering it. What it will mean, what we're trying to do is make sure that everybody understands what it's about. And we've written it, and in all fairness, it's a lot of words and it's a lot of pages and it's a lot of technical stuff behind it. But we didn't want to write it. We deal with electrical, mechanical specifications. You need a guide to understand the guide. It's ridiculous. So we've written it in a manner that people, building owners, building landlords, building users, can pick it up, read it, and understand it as a whole. And we've written it in that manner. It took a lot of, because we are technical people, it takes quite a bit to take it back to a level. But we've done it in a manner that people can pick it up and read it and understand it.
Fantastic. Well, I very much look forward to the public consultation. So obviously, we'll let everybody know when that happens. So thanks ever so much to Dave. So do feel free to put some questions in the Q&A, and we'll ask Dave to keep an eye on those and to maybe respond to those, and we'll come back if we can towards the end. And then just my colleague Catherine had a good idea. Because of the breakout thing didn't really work, so we're just going to suggest that you in the chat, you just put your name in the chat and what it is that you're working on just now, so that we can get a sense of who's doing what. That'll be really good if you can do that. So thanks ever so much, Dave. Really appreciate your time. Thank you. So I'm going to ask now our next speaker to step up to the virtual podium. So I'm really pleased to welcome Jean Hewitt from Borough Happold. She's a Senior Inclusive Design Consultant at Borough Happold. And very much looking forward to your talk today, Jean. So hopefully if you take yourself off mute and you can share your screen and take us through your presentation.
Thank you, Simon.
Thanks, Jean. That looks great.
Great. You're not seeing full screen yet, though, are you?
Not yet, no. Just
unfortunately, the box is right where I want to be clicking. So bear with me 1 second.
At the bottom right, the last icon.
Is that working?
That's perfect. Well done.
Wonderful.
Marvellous. Thanks, Jean.
So good afternoon, everyone. So I'm going to be talking to you about neurodiversity in the built environment and some work that I've been very happily involved in for the last 18 months or so. So it's a new PAS standard, basically. For some reason, my slides won't move. Hold on a second. There we go. Right. So bear with me, I've had a builder outside and my power was off and I've only just joined. So I think to start with, I should talk to you about what neurodiversity is, because there are very different views on this. And when we're talking about neurodiversity in the PAS, we are talking about the whole population, the neurocognitive profiles across everyone. So we don't come in a one-size-fits-all neurologically similar package, which typically we would call neurotypical. And there are natural and normal genetic variations in how we think and process information and so on. So we think and process information differently, we learn new things differently, we communicate with others differently, we even find our way around places differently, and we experience the world differently. How differently is a question of our neurocognitive profile. So on the top right of the screen, you can see a typical graph scenario, and there's a blue dotted line through that. There's a very straight line. That person doesn't exist. They're completely equal in every way on mathematics, swimming, English, everything. Obviously that person doesn't exist. Most of us have a sort of slight variation. We'll be a little bit better at one thing, a little bit weaker at another. And that's what the yellow line is about. That's the neurotypical line. And then on top of that, you can see a very green, bright green spiky line. And then what that's showing is a neurodivergent profile. So that's, or neurodegenerative, which is basically saying much more difference between the strengths and the weaknesses, or the differences between different things. So those are the terms I'll be using today. Neurodiversity meaning everyone, neurotypical meaning the majority of the population, not a spiky profile, probably about 70% of the population, I would think, and the other 30% will be either neurodivergent or neurodegenerative. And of course, we don't fit in nice, tidy boxes, do we? So there's lots of conditions that might come under neurodivergence, which would be dyslexia, DCD, autism, ADHD, dyspraxia, and many, many more. But actually, we're all a little bit messy and mixed up. So it's not quite as straightforward as that. But there are many people who experience challenges in the built environment that we've really not catered for to date. They don't have a formal diagnosis for a sensory processing condition or difference sometimes, so they may be undiagnosed. They could be neurotypical like myself, but with spikes in one or two areas. I'm particularly weak at wayfinding and as bad as anyone with any neurodivergent condition or worse. And there are many other conditions, of course, unknowingly affected by elements of buildings. So when we started this journey, we thought we were looking at people with the known conditions, and now we realise actually it's much, much wider than that. So examples that I've come across, some conditions that I've never heard of before, but the more common ones, migraine sufferers and people with vestibular condition, like a balance condition, all can be affected by very much the same types of things. So what happens is there is a sensory processing difference of the way our senses work with the built environment in particular. And there can be a hypersensitivity, which basically means you experience things too sensitive, if you like, to things. You can experience sensory overload, and things like bright lighting, too much noise, lots of those things which most of us will tolerate to a degree, can cause quite serious sensory overload with heart rate pounding, breathing changing, blood pressure, etc. And that can cause confusion, anxiety, mental distress, and sometimes behavioural differences. So we think around 70% of people with a diagnosed neurodivergent condition are actually hypersensitive like that. And the remainder will be hyposensitive, which means they're undersensitive to things and then would go out and seek additional sensory stimulation. The PAS I've been working on is much more focused on the hypersensitive, because that's where the built environment can have so much impact. We've got hundreds of senses. We think of 5 in particular, usually when we say how many senses, but we've got hundreds. But the ones most relevant to the built environment are basically sound, so being able to hear things, being able to see things, our proprioception and awareness of where we are and how close and all of that, and our sense of smell and touch as well. So basically, this is a new PAS. It's a PAS 6463. It was identified many years ago we needed to do something about this. And in 2006, BSI commissioned Helen Hamlin to do some initial research. It was quite a subjective research, to talking to lots of people with some of these conditions and asking them what it was that caused so much distress. And then in 2019, we secured some funding for a PAS to be developed. I'm the technical author. That doesn't mean I'm, the biggest expert available on this. Of course not. I am working with a very expert steering group of I think it's around 16 people. So what happens with the PAS, as you probably heard from Dave, it's voluntary to follow. It's got shelf life of usually less than 2 years while it gets evaluated in use. And you pick a number when you come up with the PAS, and we picked 6463 because that spells mind on the telephone keypad, for want of no better idea, basically. So the programme for this was commenced in 2020. It's currently in its draft form, 73 pages, so it's gone out for public consultation already in November. And I'm hoping that I will go through all those comments and they'll all be finalised, so we can go out late spring at a push, maybe early summer. And I'm hoping that there is a lot of potential here for this new PAS, the contents of it, to go into BS 8300, which is a code of practice for accessible and inclusive buildings, or perhaps a new part of that suite of documents. It covers both design and management of buildings, so the two work hand in hand to make an inclusive environment. And the target audiences are architects, designers, planners, facility managers, just any decision maker, employer. And the content's relevant to most building types, in fact. The only thing that we haven't covered is the very specialist provision that you might expect in a deep care setting, such as a dementia care home or a specialist education facility. We may not, only because we might not go far enough in the depths of the document. And I think that hopefully that would be a follow-on area for research. So there's 16 sections in this document, and I'm just going to quickly run through those and give you a bit of a feel for what's in there. We sort of follow the sequence of a building as you would experience on a day-to-day basis. So we start outside and then work our way inwards. So we start off, of course, with the headlines of strategy and commitment and the importance of stakeholder engagement. You need to talk to your users, otherwise you don't know what the issues are. And we've linked it to the RIBA plan of work, because most built environment professionals are very familiar with that. We then start looking at, well, okay, what does the building look like? What is the shape of it? What sort of patterns do you have on it? What happens when it gives, reflection and glare to people looking at it, and heat gain? And there's sort of a lot of things that came out of the Helen Hamlin research that told us that we needed to look at some of these issues and how they affect people. Also, the orientation of the building, so making sure that you're not creating inadvertently wind tunnels, things like that, and that you've got entrances that are readily apparent. Some of these things are already in the inclusive design standards, but we have found them more so, a deeper level of need with this one. And of course, sight lines and windows, very, very important, as they are to everyone, but also avoiding that glare. We did quite a big section on wayfinding. That was a huge issue for a lot of people. And part of that was about providing advanced information to people and allowing them some form of preview. And that could be anything from doing a virtual tour on your website to actually, when you get to your building, being able to peer through windows or have a picture of what a room might look like on the inside. And we touched on something called attentional bias. So this is where a signage and wayfinding system, we tend to expect them to be quite consistent as we go throughout an environment. And what can happen is you can get this attentional bias. If you introduce the system and then a colour or something suddenly changes later, then you literally don't see those further signs, because the brain is then not looking for them. And this can happen to quite a lot of people. The use of colour and, of course, technology was important factors as well in wayfinding, as well, the traditional inclusive elements of accessible signage. We also touched on external spaces and access to nature, because biophilic design was felt to be very, very important for mental well-being, and I'll touch on that towards the end of this talk. But views out to nature, very reassuring and very grounding for many, many people. On internal layouts, we're really looking for areas where you can transition from one type of area to another without it feeling dramatically changing. So you sort of take people on the step change through an environment. And we looked at layout and symmetry for lots of people had a need around that, rather than a confusing building or a labyrinth building in terms of corridors and so on. A lot of people felt that there needed to be some familiarity around the space. So anything that's very novel or new perhaps needs to be introduced in a gentle way, and providing a clarity of the space. You actually felt like you were grounded, you knew where you were, you could orientate easily. And if you applied this to sort of office type environments, you might even want to have control over where to sit, where practicable. So that was giving people choice. So you could have noisy areas, you could, collaborative areas, you could have quieter areas, and giving people that choice is very, very liberating and very, very helpful to people who had this hypersensitivity, because they can't quite often tolerate too much noise or bustle, too bright lighting and so on for a prolonged period of time. Interestingly to me, because I didn't expect to be looking at this, we also looked at some of the MEP, mechanical, electrical and power type items, and because a big part of that was, of course, olfaction, the sense of smell, and the off-gassing of carpets and other substances and chemicals that are in the environment, and perfumes that we use when we're cleaning products, things like that. So trying to eliminate some of those, and either through not having perfume products in the first place, or where it was sort of off-gassing or products in the environment that were causing the VOCs, doing a flush through and things like that. So FM type solutions for those. And we looked at, the switches and controls of things like lighting to try and give people a bit more control over the environments. Noise was a huge issue for a lot of people. So we did look at acoustic layout and zoning, things like that, offering different options for people. So we've not invented completely new standards on a lot of this. What I've done is I've gone out and looked for standards that were already there. Perhaps people weren't following them or didn't realise that they could be useful in another type of environment. And an example of that would be Building Bulletin, where it talks a lot about the acoustics in terms of children with special educational needs. There were some good values there that we thought we could bring across into the PAS for, say, a quiet room in an office environment where people didn't want to be sensory overloaded. We had on the acoustics, we had a representative from Ecophon, the acoustics company, and the steering group also included input from acoustics where I work. And then on the lighting, that was another big area. So I would say acoustics and lighting are the two biggest areas. So the issues of daylight, yes, we love it, but you can have too much of it when it causes glare or deep shadows. How we reduce flicker. We knocked down a few myths about lighting types, because to date people said, oh, take the fluorescent lighting out and put LED lighting in, but it's not quite as straightforward as that, because LED can have a flicker too if you're not careful. So it's talking about the designer lighting. We did find that colour temperature preference was generally a warmer light, and the good colour rendering index of at least 80 was helpful for people with neurodivergence who'd be processing that information in a different way. Even things like the illumination ratio between, the desk where you might be working and the corridor alongside was quite an important measure too. So loads of cross-referencing to various standards on acoustics and lighting. And the most important things was, can we give people adjustable lighting? Can it be adjustable, please, in colour, temperature and lux? Because that was really, really helpful. Colours muted rather than vivid, so too many bright colours. You can have bright colours, but be careful where you put them. And we looked at visual contrast, particularly at things like floor junctions. So some people, like people with dementia, which is a neurodegenerative condition, struggling to cross over a vast colour difference. People with visual impairment, of course, might just misinterpret that anyway. So generally calming down some of the colour schemes certainly in the buildings where you would sit all day. And we even looked at patterns of when you lay carpet tiles differently and what can happen and how that can distort the vision. We did quite a bit on fixtures and fittings, even things like, soft close cupboards and quiet flush, and using natural materials for biophilia, really, really helpful too. A big area, safety and recovery, particularly quiet and restorative spaces. We've heard about quiet rooms creeping, quite a pun, creeping in everywhere, but a lot of people are looking at quiet restorative spaces now. You're seeing all the big football stadiums are doing them, lots of busy shopping centres are beginning to add them, airports and so on. But there's no real set guidance on how you do them. So we've been a bit brave on that section, informed by a student I was working with who did some lovely research on it. And we've come up with a set of guidelines about the things that you need to consider. So hopefully that will be very helpful to anyone considering a new quiet room. And just to say that obviously if you have a neurodivergent condition, you doesn't mean you've got a mental health illness, but our neuro profile does have a part to play in this because of this ongoing impact on the senses that can happen when you're hypersensitive to environments. There can be an increased chance of having poor mental health or well-being just because the environment's not meeting your needs. So it's a really important thing for us to try and improve over time. So biophilic design, of course, incorporated anywhere in a building is helpful, but also applies equally to that quiet space. So in summary then, what the PAS is about is an environment that has some clarity to it. Now, the clarity comes from reasonable acoustics and sensible lighting and clear layouts and all of the things I've just talked about. We also want to see more choice and control given to users, whether that's choosing to sit somewhere different because they've got that choice, or having some control as in adjusting lighting and things like that, or maybe pulling an acoustic curtain and being able to change how it works. And finally, if all else fails, certainly a calm space where you can escape when it all becomes too much. So just an infographic there that we've developed for the BSI at Bureau Happold, and just showing all the different elements around the edges, and then in the middle, those three umbrella terms, really, the calm, the control and the clarity, which we would like to see going forward. So that's what it is. It's called PAS 6463, Design for the Mind, Neurodiversity in the Built Environment. You can still look at that first draft live, even today. But just bear in mind that we've had lots and lots of comments in. I don't think the comments have made drastic changes, but it's a lot of tweaking going on. So I do hope that we'll get that out to you and you'll be able to obtain a copy of that, as I say, late spring, I think. Thank you. So I'll stop there and see if there's any questions. I haven't had the chat switched on. Can I stop sharing my screen now?
Yeah, thanks, Jean. If you stop sharing your screen, that's a fascinating presentation. Thank you so much. So yeah, so if you've got questions for Jean, pop them in the Q&A. There's a few coming in there, but none, I think, at the moment. But no doubt they'll start to trickle in. What we'll do is ask our audience to pop any questions they have for Jean in the Q&A there, and I will ask Jean to keep an eye on them and to have a look. Feel free to comment on the other questions that are coming in. So, and just to say that we are writing up the proceedings, so I'm pleased that Hattie Hartman is with us today, so a well-known journalist who's volunteered to write up the proceedings for us today, so we can have a sort of an overview and a summary, which is great. So thanks to you, Hattie, for that. And I should have mentioned right at the start, really, but many thanks to our sponsors for the Healthy Buildings today, which are Wienerberger and Barico. So many thanks to you guys. Yeah, okay, so pop your questions in the Q&A for Jean, and in the meantime, we'll move along. So I'm going to introduce Amanda now, to ask Amanda to come to the podium and take yourself off mute and share your screen. How are you doing, Amanda? Are you all right?
Yes, I'm fine. Thank you, Simon. Thank you very much for having me.
You're very welcome. Thank you very much for talking to us.
So I'm just going to try and share my screen. So just hold on one sec, please. And I'll patiently get there.
There we go.
Hopefully you can see that all right.
Yeah, just need to pop it into presentation. There we go.
Okay, good. Well, thanks very much, everyone, for the opportunity to speak this afternoon on the Code for Construction Product Information. To explain, I am the Chief Executive of Construction Product Information Limited, which is a new not-for-profit organisation that's been set up to manage and verify this code. Just so you sort of get a sense of the context, I'm also the Chief Executive of the Considerate Constructor Scheme, which I'm sure many of you will have seen whenever you're pounding the streets or driving around and there is a construction site. Very often they are registered with the Considerate Constructor Scheme. And then I'm also the Chief Executive of another fairly new organisation. It's only been going a couple of years, which is a Building Safer Future Charter, Building Safer Future Limited, but it's actually the organisation that runs the Building Safer Future Charter. All three organisations are working to raise standards across the construction sector and to build public trust. All three organisations are in some way or other particularly supporting the efforts to drive a leadership and culture change across the industry, particularly in relation to sort of ethical behaviours and building safety. All schemes are not for profit and they all have independent governance, and all of them have elements of monitoring or assessment or verification. And so the one that I've been asked to focus on today is the Code for Construction Product Information. Where that comes from is if we think back to the Grenfell tragedy, the fundamental conclusion out of the Hackett report following that tragedy, that is pretty inescapable, is that there was a total failure of leadership and a cost minimization, speed maximization culture that lay at the heart of the disaster. And what Dame Judith Hackett said was, to deliver safer buildings and safer homes, the construction sector needs to urgently change its culture and its leadership. So that's where Building a Safer Future has sprung up from, to answer that for most of the value chain across the built environment sector. And it's also where the Code for Construction Product Information has come from, because particularly Dame Judith Hackett raised serious concerns about misleading and fundamentally incorrect marketing information around construction products. And so that's where the CCPI, the Code for Construction Product Information, is seeking to address that concern that Dame Judith Hackett raised. So just to explain the development journey, the Code for Construction Product Information originally came from the CPA, the Construction Product Association. After Dame Judith Hackett wrote her report and raised, among the others of her 53 recommendations, the serious need for culture change across the sector. Of course, that applies too to manufacturers, construction product manufacturers, and particularly raised this concern about disingenuous marketing practices and misleading product information. The Construction Product Associations have picked that up and said, well, we've got to ensure that this becomes a thing of the past. So they created a thing called the Marketing Integrity Group, which brought together a whole team of marketing and technical experts coming from all the different aspects of the building of construction products. So light side and heavy sides, air conditioning, all the different elements, and they sort of came together and looked at what the issues were. They did a call for evidence, which went right the way across their membership in the industry in 2019. And that brought out a sort of general agreement that there needed to be some sort of code specifically about construction product information. And then they developed the code, the Marketing Integrity Group did. And I was part of none of that. That all happened before CPA came to myself and the Considerate Constructor Scheme, having seen what we'd done in setting up the Building a Safer Future Charter, and asked us, would we be willing to take on the code and assess it and verify it. So they handed over the finalised code to us, and we set up construction product information. We are about to bring in an independent chair and our board, so that we can manage and administer it going forward. And it does have the benefit, because it sits alongside as a sister scheme to Consider It Constructor scheme. It does have the benefit of being able to use this sort of economy of scale that we have. So that was the sort of journey that they went on, and their consultation that they did with the industry was really substantial. They ultimately won a market research association award because they had done such a good job of their consultation. They managed to get really solid feedback from 28 trade associations and other member bodies, and then they also had individual respondents. So ultimately they were covering some 30-odd thousand members of those associations who had been engaged in this process. There was a lot of support and understanding for the things that went into the code, and certainly there was a lot of positivity about the possibility of being able to engage with the code. Although I think it's fair to say that the construction products manufacturing sector does also recognise that it's got a fair stretch to do with some aspects of the verification process. So the code was then handed over to CPI Limited, and it is structured in 4 sections with 11 clauses. So there is one whole section which is about information creation, and that covers the need for the organisation to have processes in place that manage the creation of information by competent people, that it needs to be approved before being issued, and that there needs to be managed version control. And all of that is aiming towards product information that is clear, up to date and unambiguous. The second section of the code is all about the core information. So the core information section describes the basis on which performance claims may be made. There's a requirement to include physical characteristics and to ensure that the information is consistent with the supplied product, and also that change management processes are put in place. All areas of substantial concern that Dame Judith Hackett was raising at the time. Then the next section is about associated information. So there's a need in that section for the information published on the website to be fulsome and complete regarding things like the installation, the use, the maintenance and the disposal of the product. There also needs to be detailed guarantee and warranty information, and making very clear where there are exclusions. And then the final section, the last 2 clauses, are all about ensuring that there's appropriate support and competence behind the management and putting together the product information, so that there are technical helpline details in place and that there are competent individuals able to support that, and that in fact there's a competency process in place for all those involved with product information. So the code and the verification process seeks to address the findings that came out of Dame Judith Hackett's report, and the anticipation is very much that CCPI product information verification will also help meet compliance with some of the anticipated construction product regulation that's coming out. It is important to say that it's early days for the code, and I could see very much the possibility for those core sections and 11 clauses to develop going forward, and possibly to link up with requirements in relation to sustainability or provenance or sort of other possible requirements. I could see that if there is a need for that, that will potentially happen. But the starting place is Dame Judith Hackett's report and the serious concerns that were raised there. We wanted to make sure that robust verification is put behind this code. My background comes with a large chunk of working as Director General of a global umbrella organisation, working for consumer protection and championing consumer protection. So I do like to champion and believe in the importance of independent third-party verification rather than perhaps a code that organisations can make claims against but aren't proven. So when CPA came to us and asked us to manage the code for construction product information, we were keen to make sure that there was a verification process behind it. Ultimately, the CCPI verification is a confirmation that product information published by the manufacturer is clear, accurate, up-to-date, accessible and unambiguous. So it's really important to pause for a second on what we're not doing. Because particularly when talking to construction product manufacturers about this, we want to make sure that there's no confusion. We're not testing any products. We're not setting or approving or recommending construction product standards in any way. We're not recommending any management systems or manufacturing controls. And we're not making any assessment of construction products performance or recommending changes to construction products. What we do in the verification process is fundamentally, we check that the product information management system the product information has management systems that work against to support the 11 clauses of the code. We then seek to corroborate that the product information that's being provided is clear, accurate, up-to-date, accessible, and unambiguous against the code and against the manufacturer's own management systems. And we do check the performance statements made by product information against the formal certification or the classification or testing done by third parties. And fundamental to all of that, we also do work with the manufacturers on their leadership and culture within the organisation, which is the support base of those management systems and the behaviours that we're looking for within an organisation. In setting this verification process up, we've really had to work through how we make it work. So registration with the Code for Construction Product Information Scheme has to occur with either the company or the brand that a product set or a product, because sometimes it might just be one company with one product, is traded under, and it's whichever of those is closest to the product or the product set. And it may be that a company will seek to verify the product information in relation to 2 or 3 product sets. We're not verifying the company, we're verifying the product information around those product sets. The actual Code for Construction Product Information verification process has 5 steps to it. The first one is a really important step, and it goes back to that initial point that I was making about Dame Judith Hackett and her overarching statement that actually is a total failureship of leadership and culture within the construction sector. So we won't work with any organisation that doesn't have a leadership and a culture that puts building safety first. And so that first step, the leadership and culture survey, is itself a very important piece. It's actually drawn from the Building Safer Future Charter, one of the other organisations I mentioned, and that in its turn has been drawn from the learnings of cultural maturity scales, 9 other cultural maturity scales from major hazard, from industries that are much stronger on major hazard safety, such as oil and gas, chemicals, rail and nuclear and aviation. So the leadership and culture survey is the baseline. We won't work with an organisation that doesn't pass an acceptable level on that survey. just to sort of pause on that, what it actually does is looks at the perceptions and the cultural norms within an organization. We all know we can't measure culture and leadership like we can temperature. So using those cultural maturity scales from those other major hazard sectors, actually what we've done is built a survey, a psychometric testing survey, which goes across a statistically significant proportion of a company's staff to understand the perceptions of the cultural norms within an organization. And then that survey is assessed on a maturity scale, which ultimately will help the organization to identify areas of continuous improvement, but also helps us know that we're working with organizations that have the right leadership, culture, behaviors, ethics in place to be part of then putting forward product sets with product information that we are seeking to verify. And it's a very important sort of safety net that sits as a sort of the gateway, the starting point for getting CCPI verification. We then move on to the second part of the verification process, which is not just to look at the organization's culture and leadership, but also to look at their management systems, and particularly to look at the process that they are using to manage product information, the communication channels for changes to product information that they have in place, the processes to ensure that employees who are involved in product information are competent, so whether there are competency matrices, training qualifications, and so on in place. That piece of work goes hand in hand with the leadership and culture survey. The leadership and culture survey gets validated by structured interviews with a CCPI verifier who will look across the survey and the responses in an organization, look for outliers, anomalies, concerns, and seek to interview to test them. The management systems are then verified using an evidence-based approach with some validated validation structured interviews where we see issues. What comes out of that is a narrative and statistical assessment report of cultural maturity and management system conformance with the code that helps identify continuous improvement for the organization and gives us a baseline of trust to be able to work with that organization at then looking at that organization's product information. If the organization achieves a standard of conformance, then they can proceed to steps 4 and 5 and to getting product sets verified. So then moving on to step 4, once the organizational assessment is completed and then the verification process for product sets gets opened, and then organizations are required to provide evidence of conformance with the code in order to get verification for that product set. And that is a number of things, from there being a single person or multiple people responsible for the information that is managed around each product set, any certification, classification, industry approved standard that they hold for the product set, or if there's a self-declaration of performance of products and evidence to back those up. We have to see the product information that's being made available for customers, whether that's on a website or in a brochure. We have to go through warranty and guarantee information. And we also look further at the competency requirements and the evidence of competency for those involved in the product information around that product set. And all of that has to be provided to us. And then we move to product set verification, which is a mixture of human-led verification processes and then also some automated processes, because you can imagine there are thousands of product sets on the market with product information linked to them. If they get through the process, then they are awarded a uniquely numbered verification mark, which is licensed to the product set for 2 years although in the second year there are some random checks as well. And of course, the organisation will get a report from CCPI where there might be areas where we would want to see some continuous improvement or development in relation to how they're managing product information. It's worth sort of just mentioning the definition around product set or system or product group, as they're sometimes called. A product set is defined by either a group of similar products fulfilling a common purpose, or a grouping of dissimilar products but that are in a system fulfilling a defined function. So you might have roofing or a window system. Where there's similar products, CCPI won't be differentiating them by size or colour unless that changes the performance of the product in a safety critical way. So therefore, generally products forming a similar purpose with similar performance characteristics would be submitted as one product set by that company. All products that are required for a system to function are supplied by the manufacturer as part of the product set. They have to be included in submission in a submission together. So you might have a grouping of products that could be a collection of different plasterboards that are certified to the same standard, but they're available in different sizes and widths. Or you might have a collection of drainage pipes, again certified to the same standard, and that's the key, but available at different lengths or widths and colours. So in that case, they will all go together with providing us with the certification to the standard. But as I said, with the product system, well, it could be double glazed window sold, and it might have glazing or a glazing frame, seal, hinges, handles. They're all included in the system, but the whole thing's sold as a single product. So all of that would come together as a grouping. So that is how we are breaking them down. In terms of
2 minutes, please, Amanda, please.
No problem. In terms of next steps, the registrations will go live for manufacturers. We'll do a couple of smaller initial waves, which will be starting at the end of we expect Q1, assuming that we can finalise our PII in our professional indemnity insurance for the scheme, because there are lots of issues between the insurance sector and construction products that we're having to navigate. There's guidance online of most of what I've talked through in those links, and we also have a major event on the 24th of March, which is all about culture change, and where some of the organisations that went through the pilot for this will talk about what they experienced, and some of the organisations who are lining up to do it will talk about why they've lined up to do it. So hopefully that gives you a really good overview, and again, happy to pick up questions as they come forward.
Great, thank you so much, Amanda. Really useful. Maybe I can ask you to keep an eye on the Q&A. There's 1 or 2 questions creeping in. I'm just mindful of time. So what we'll do now is we'll bring in our final speaker, who's Mark McKenna, who's the founding director of Down to Earth. So Mark, if I can ask you to share your screen and introduce yourself and take us through your presentation. Many thanks. And thanks, Amanda, fantastic. And thanks, Jean, and thanks, Dave, for answering all the questions. Off you go then. Thanks, Mark.
Thank you, Simon. Hello, everyone. So yeah, hope you've had a good afternoon. So yeah, I'm mindful it's 10 to 5, so I won't I'll go on too long. I'll get short and sweet. So my name is Mark McKenna. I'm one of the founders of Down to Earth. Down to Earth's social enterprise based in Swansea. So I'm going to share some thoughts on sustainable construction, how it can be used as a tool to deliver healthcare and education. I'm going to emphasize the healthcare side of it. I'm just going to assume everyone attending this is fully on board and familiar with the benefits of natural materials, and I think we're all quite familiar with the health benefits of working or living in spaces that are built with natural materials. I'm going to be emphasizing how the process of engaging with the materials and creating buildings using natural and sustainable materials is good for people and improves health outcomes. So just a brief background about Down to Earth. So we've been running for 16 years. We have 2 social enterprises, and we're very interested in how healthcare and education can be delivered through the medium of sustainable construction and sustainable land management. We've got a strong social inclusion agenda, so we're very interested in how you can tackle social inequality whilst concurrently tackling environmental challenges. We see the 2 going hand in hand. Some of the ways we work, so very focused on generating the evidence base, which is going to be the thrust of what I'm going to share with you guys this afternoon. Very interested in cross-sectoral ways of working, so moving out of the traditional siloed areas of work. And we see our role as proving concept, working in spaces that aren't ordinarily developed. And then once that concept's been proven and the evidence base is there, it enables scale and replication. We have some pretty strong values which we stick quite robustly to. I won't go too far down that route, could spend all afternoon talking about that. But I guess it always seems impossible. And I guess that was slightly on my mind with some of the current affairs, but more on the sort of positive angle of that with Nelson Mandela's thoughts on it always seems impossible until it's done. We very much believe in doing what may sometimes not be deemed possible, proving it is possible, and then empowering others, developing confidence to take things forwards at the scale we all know we really do need to do. And I guess that's why we found that the evidence-based and clinical research is so critical. I think intuitively we all know these things are good for people, good for ourselves, good for nature. How do we prove that? That's been one of our key drivers. So we've done some pretty lovely buildings, quite architecturally exciting. I saw Barbara Jones somewhere in the sidebar participants. So we worked with Barbara on the rear side of this building, which is Straw Bale, round pole reciprocal. So that's the sort of background we've come from. And we're interested in what does community-led sustainable construction look like? We're very focused on working with some of the most marginalized and vulnerable communities in our society. We work a lot with asylum seekers and refugees, a lot with neat young people, a lot with health boards, adults and young people who've had a stroke or brain injury or are experiencing psychosis or are in low secure mental health units. So we've got quite a holistic way of working which concurrently tackles environmental challenges, delivers educational outcomes, tackles poverty in a whole range of ways, and also delivers healthcare. So I'm going to focus just on the latter point, on delivering healthcare. 2 case studies to whistle through. First one is these 6 social rent houses that were built for Coastal Housing Group. So these houses were built with Welsh timber and natural insulation and a tartar steel roof made in Port Talbot, covered in PV, south facing, solar centered design, everything I'm sure you'll all be expecting and hoping that we'd be building like. So the key thing, I guess, is it was funded through the Welsh Government's Innovative Housing Programme. And these 6 homes, social rented properties, were all built through a healthcare and education centered model. So there was a range of adults and young people involved, nearly 200 participants involved. We were, as you might expect with a recent build, impacted with the pandemic, but we worked really hard and the funder was super supportive in enabling the scheme to progress in spite of some of the obstacles that came with the pandemic. But we're talking about adults who are from the local health board, a lot of asylum seekers and refugees, a lot of neat young people involved in the off-site manufacturing of an open panel system, and the on-site assembly, and involved in every element except the M&E. The participants were involved in every element of the build, and it's through the creation of those homes that we've delivered on the health and education outcomes. And I'll come to how we research and prove that impact shortly. And the second case study is based on UHL, so University Hospital Llandoch, which is part of Cardiff and Vale University Health Board. So this is the UHL campus, as the second largest hospital in Wales. We're working with the staff, patients, and the wider community for that matter, in the design, build, and then once completed, the ongoing maintenance and use of a 14-acre outdoor healthcare facility. So it's quite a radical approach. We've involved staff and patients through the full process of the design, and we're now at implementation stage. So you can see, if I move my cursor, this is the main campus, and then abutting the campus on the west side, a 7-acre meadow here and a 7-acre woodland underneath. So it's an amazing opportunity to show how the NHS can integrate an outdoor approach to healthcare delivery, with critically the big difference being staff and patients designing and building that infrastructure. Now, as you might expect, that's entirely using natural materials, and it's an edible landscape. And then a first for Wales is working with the Kite Marker accreditation of Building with Nature, which is a Wildlife Trust-led green infrastructure accreditation scheme, which for us is really important to externally validate the claims that we make about biodiversity enhancement for the site. So that's also Welsh Government funded through an NWAR programme called Enabling Natural Resources and Wellbeing. And yeah, we're fortunate in Wales. I don't know how many attendees are based in Wales. It's pretty progressive government and legislation to enable quite integrative ways of working. So these are some of the projects that are either ongoing or recently completed and demonstrate the ways that we work. And that's one of the rendered images for what the therapy centre will look like. So that's more on the built environment side of what we're doing: foam glass insulation, wood fibre insulation, Welsh timber. And yeah, really exciting to see how the staff and patients will get involved in that construction process. So onto the research. So the most recent research which has been published is in the International Journal of Mental Health. So that's, as you can see there, they're sort of using engagement in sustainable construction to effectively develop a new green healthcare approach. So that's based on 5 years of data. And the key synopsis is that it's been deemed as effective as antidepressants in reducing depression and anxiety levels. So that's an evidence base that can be used by the sector. The research could get broadened to look at, participants or people who are not from a disadvantaged or so-called hard to reach or vulnerable background. But we very firmly believe that to tackle social inequality and to take the world of sustainable construction and natural construction outside of a very specific socioeconomic group, it's critical that we work with the most excluded. So that's always been our focus of research. And then there's another paper which is imminently due to be published in the same journal, International Journal of Mental Health, on inclusive measures. So if we are going to become more inclusive in our way of working, and we want to become more inclusive in how we measure, so that the measures don't unintentionally exclude a particular demographic, i.e. people who may not be able to read particularly well or have particular levels of emotional intelligence that enable them to engage with a questionnaire, which is based on the psychological state. We've been quite keen to look at new ways of developing measures that enable all sorts of people from all sorts of backgrounds to be able to measure how their depression or anxiety is. So that is also about to get published. This work all takes, as you can see at the top, it's 5 years of data. We've been working with Swansea University for 12 years now, and we're working with Cardiff University as well on the research on the new Velindre Cancer Centre, which is another scheme which we're involved with. And I guess the sort of key points that we'd share on it is you need to start early with the research, given the lead-in time and the data that needs to be aggregated over a period of time, and also to have a long-term view on a future-facing view on what we feel collectively across the sector will build the evidence base for effectiveness of the way of working, and to show that it's not just about occupancy of the properties and how they're good for people, but it's about the process of engagement and creation of buildings using sustainable materials, which is as important. So, final points on what's going on next. So there is ongoing clinical research. We're looking at nature connection. Probably more importantly, we're looking at impact on NHS staff members. So this was a concept and research brief that got funded pre-pandemic, looking at how do we build resilience and reduce burnout in the NHS workforce. So those NHS staff members are also engaging in programs. The world of SROI, or social return on investment. So financially, what are the metrics on the impact of this approach? Green infrastructure accreditation, so I've mentioned building with nature, and embodied carbon. Those are areas which we are looking to work with other bodies to externally validate the work we're doing. And then build-wise, we're doing more and more hospital infrastructure. We're hoping to get into school buildings as soon as we can. And then homes, yeah, plenty of exciting schemes in the pipeline with homes. So I think I'm pretty much done with time. That's how you can connect in. Yeah, and I know that's been a bit of a whistle-stop tour, focusing on the clinical research, but hopefully that's given you what you need. And if you'd like to have links, the research is all on our website, but I can send you direct links. We've paid for the research to be open source, so anyone can access that.
Fantastic. Thank you, Mark. That was incredibly a lot of information and a lot of work delivered in a very slender time frame. So thank you very, very much for that. I really appreciate that. So I'm sure there are a pile of questions here, but I'm also mindful of the time. So we've had something like 30 questions that we've answered as we've gone through. What I'm going to suggest that we do is we probably should wrap up now, unless anyone's got any burning questions for Mark. You can always pick them up from the website, or drop Mark a line, or indeed drop us a line, and we'll put you in touch. So bearing in mind that we're now over time, I think I'd like to just thank everybody who stayed with us through the afternoon. It's been a fascinating roller coaster ride through the afternoon. I'm very much looking forward to watching the presentations again. I find it quite difficult to take in information and keep an eye on everything. And also look forward to Hattie Hartman's write-up, which is always going to be useful and informative, and hopefully answer any further questions that come through. So we'll send out the recording of the presentations and the presentations to you all. And also we'll send out the Q&A and the chat, because thank you so much for putting all your stuff into the chat. we've got quite an eclectic range of folk on the call today, and in a real world, of course, we'd be having a glass of wine and we'd be having a chat. But there we are. It's coming, I think. So next week we're at Future Build in the Excel Centre in London. So we have a stand there. So do come and say hello. But it just remains for me to say thank you all to our amazing speakers. Thank you all for giving up your time and contributing to what's been a fascinating afternoon. We look forward to working with you. I think, Mark, it would be great to do perhaps a longer session with you, and the same with Jean and Amanda. So we'll come up with some ideas and get in touch. So thank you all. It's been a fascinating afternoon, and we look forward to seeing you sometime again in the near future. So cheerio.